Hello, test 1, 2, 3. Hello, test 1, 2, 3. I think that's it. talk to me and we'll figure out why you haven't had a good JavaOne. Anyway, so I thought this would be a good talk towards the end of the presentation. Sorry, the end of the conference. It's called Reactive Java E, Let Me Count the Ways. Let me start the talk with a story, if you will, the story of the genesis of this talk. So I was giving a talk at another Scandinavian conference called Oradid on a Java E talk, of course. And then at the end of that talk, a gentleman comes up to me and he says, hey, have you heard of this term reactive? And I said, yeah, of course. It's usually the Scala and Akka guys, so the hipster guys keep talking about it. Why? And he said, I don't think so, because I really think I'm developing a reactive application in Java E. And I said, interesting. Let's talk. So we scheduled some time at a coffee house in Malmö, Sweden, and he sort of took me through his ideas. And what I realized is that actually he is exactly correct. So the ideas are actually so good that I decided to make a talk out of it and sort of share those exact ideas with you all. And I've been doing actually this talk for about a year and a half or so. So before I dive too much into the talk and show you how you can write sort of very reactive applications with nothing much more than just vanilla Java E and Java SE, let me tell you one more thing. There's a lot of slides here, a lot of material to cover. I may not necessarily cover all of the material. If I don't, I'll give you the slide deck. I think as we go through the slide deck, it will be obvious to you, what the rest of the content is, even if I don't go through it, I manage to go through it in this one session. Also, the other thing that I want to say, and this again goes towards not necessarily finishing all of the content that I have in my slide deck. I do usually run my sessions as open Q&A. What that means is, if you have a question on anything, let's stop and discuss it then, as opposed to waiting later to do so. And in fact, I suspect, for this particular slide deck, there will be quite a few questions that we should discuss. So we should go ahead and do that in line instead of later. Okay. Absolutely horrible way of starting any talk whatsoever. I need to show you a legal disclaimer. This is a standard Oracle legal disclaimer for any forward-looking stuff. Actually, I don't need to particularly worry about this in this talk, because for the most part, I'll be talking about Java EE 6 and Java EE 7 features, and that's past and current state. However, I will be talking about some things around the future, perhaps Java EE 8 and beyond, and this is what sort of CYA slide is there for. Okay, so how do I plan to spend the rest of your time in about 50 or rather 55 or so minutes that we have left? This is my plan. Okay, so first and foremost, I'm going to talk a bit about exactly what reactive is. And believe it or not, this is going to be probably the most contentious, great, not straightforward part of my talk. Okay. And then, for the most part, we'll actually be spending time doing a relatively fast-paced tour of exactly what are the reactive features in Java E. And then finally, we'll also talk a bit about what Java SE 8 offers. Java SE 8 actually offers quite a few interesting features with regards to reactive as well. And we'll see how those features work very nicely in a Java E environment to give you really a pretty good mechanism to write these sorts of applications. Okay, to start in the beginning, I assume if you're in this room, you probably have heard of the term reactive, otherwise you probably wouldn't show up here, kind of scratch your head and wonder what the heck is this thing about. So let me start by asking, how many of you think you have a concrete grasp of what reactive is? My, we have some self-confident people here. Okay. The reality is, reactive is an extremely vague term, and it gets more and more vague by the day. It's one of those unfortunate terms like SOA and microservices that sort of have their genesis in a relatively simple concept. And what's happening is, what happens in our industry quite often is sort of modeling of that term by adding more and more baggage to it. Okay? So for me personally, it took me quite a while to arrive at a definition of reactive programming that I am comfortable with. Okay? So this is a definition I've arrived at. It's on screen. I'll explain to you what this is. I really think this is at the heart of it. This is the kernel of truth behind what reactive programming really is all about. You notice those four line items I have broken out in my slide deck. By and large, if you are dealing with any one of these concerns, you are essentially dealing with reactive programming. In fact, the more of these concerns that you are dealing with, and the more these thoughts are familiar with you, the more the chances are you're dealing with reactive programming. Believe it or not, the term reactive actually entered the technology dictionary quite a while ago, around the mid-80s. The original definition of it is simply, a part of it, simply that a part of a program reacts to another state change in another part of the program. A classical example is a Excel spreadsheet. Okay, so when you have an Excel spreadsheet and you have two cells that are interrelated, you have formula in one cell that depends on a value on the other cell. When you change the value of this dependent or originating cell, the dependent cell's value that has a formula in it also changes. That's the original definition of what reactive is. And we've sort of danced around this, but the core idea is very much similar to that concept. So basically, if you're dealing with event-driven programming, and that is simply receiving a message from an external system or a state change, and you react to that state change in some way, that is reactive programming. Chances are you're dealing with reactive programming. If you're dealing with asynchronous concerns, meaning doing processing in a thread other than the currently active one, that is also very likely a reactive programming concern. Non-blocking code, code that you are attempting to not block the current thread, that is also a reactive programming concern. Similarly, message-driven programming, very similar to event-driven programming, very subtle differences. These are also reactive programming concepts. Now, if you look beyond these core values, these are sort of core concepts that are common to pretty much every thing that claims to be reactive. Other than that, of late, there are a few other other terms tagged on to and gone along for the ride of these basic core principles. And these are words like responsive, resilient, fault-tolerant, elastic, adaptive, scalable, and so on. And the list sort of keeps growing. By and large, what I see is that we need to apply Occam's razor to this and really arrive at the simplest possible definition, because that ultimately is the correct one. And most certainly from the JavaOne standpoint, you can do so. What I will argue is that these other concerns, things like responsive, resilient, fault-tolerant, and so on, it's not that they are not important. It's just that they are important regardless of whether you are writing event-driven, asynchronous, non-blocking, message-driven code or not. Even if you are dealing with a CRUD application that is blocking and synchronous, you in all reality still need to deal with these concerns. These concerns are not unique to reactive programming at all, and hence it doesn't make sense to tack on these concerns with reactive programming. From a JavaOne standpoint, it really doesn't make sense because JavaOne deals with a vast majority of these concerns at the runtime level, not at the API level. And we've done so for many, many years. And that is because these are system concerns rather than necessarily programming concerns. You can get reactivity and fault tolerance by the runtime providing it for you. You can get elastic, adaptive runtimes by having elasticity and adaptive programming built into your cluster. You don't have to deal with this in your application. Scalability should be a concern for the runtime, not the API. Okay. I'm by and large going to ignore these things. I'll about them a little bit during the presentation, but by and large, we will stick to these core 4 principles for the most part. Okay. So this is a bit about how I arrived at that conclusion, and you'll see the correlation behind it. In the end, reactive programming concepts, as I mentioned, actually have been with us for a very long time. Okay, so what is it that in the end we are trying to accomplish with reactive programming? That's what's important, rather than arguing too much about what the definition of reactive programming is. So the goals that we're trying to accomplish are, some of them are listed here. So first and foremost, we want more responsive user interfaces. Okay? This is very, very simple and has been with us for a long time. So a classical example of this is your little rotating mouse, okay, in Windows. So if you do something, okay, and it's a long-running operation, you don't want your user to be waiting around and wondering whether your application is reacting to user input. So what you do is you have some visual cues, something going on in the front end to indicate progress or indicate things going on behind the scenes, and do the actual processing behind the scenes. And lo and behold, this again goes to those concepts of asynchronous programming and event-driven programming and non-blocking I/O. Right? We also want high throughput or optimal CPU and hardware utilization. And how do you do this? You do this by making intelligent use of threads and making intelligent use of I/O. Again, this goes back to the issues of asynchronous programming, event-driven programming, and in I/O. And for some systems, reactivity actually comes quite naturally. So these are systems where things are actually driven by events, right? And they produce events as well. I actually we used to work on a system like this. A trading system is a good example of this. So in a trading system, what you have is that it's a large state machine that reacts to events. Okay, stock trades happening, and then it produces events as well. It actually doesn't produce any UI output directly. It simply says, okay, this is the state change that I think occurred. Please broadcast the state change to whoever it is that needs to know about it. Now, if these things have been with us now, why bother creating a new term? There's a few things happening in the industry that potentially makes these age-old things a little bit more relevant to us today. And one of these, the principal drivers of these things is something called IoT, or Internet of Things. Anyone heard of Internet of Things? Yes, I go? All right, very good. So what is the deal here? What is the connection between reactive and Internet of Things? Well, by and large, the Internet that we have today is user-oriented, human-oriented. So it's humans interacting with machines. So we humans actually are relatively slow, right? So we have built-in think time in whatever we do. We click on a screen, we look at the input, we look at the output, and then we think about what it is that we need to do next, and then we click on the next button. As a result, it's relatively easier to deal with human-to-machine interaction, because a machine is generally much faster than a human is. Don't get me wrong, we still have scalability challenges, clearly, but it's easier because you're dealing with an asymmetric processing capacity situation. Now, in the Internet of Things, it's really a machine talking to another machine, which means that the frequency and volume of processing is a lot higher, hence putting more demands on the system. Right? So again, that means thinking about things like high throughput and optimal CPU utilization becomes more important in this one. Also, some folks will argue that we're suddenly in an era of large globalization, whereas our systems used to be very local. We service local markets. Now we are servicing global markets, and hence we have to deal with a larger user volume and larger number of concurrent users. If that is in fact the case, again, that is a good case for really thinking about how to do more with less hardware. Okay. So all that being said, let me finish with a caveat. Okay? And you'll see this caveat in action as we sort of iterate through the reactive features that are in Java EE. Just like everything else, reactive programming is not a cure-all. Okay? What you'll see in my code base is that asynchronous event-driven code, no matter how you slice it and dice it, is significantly harder to write and maintain than synchronous blocking code. The reason for this is the human psyche itself. Okay? So we humans are parallel processing capable machines. In fact, that is what's going on. As I'm speaking here, my heart is pumping, my lungs are working, but my perception of the world, by and large, is synchronous. Okay, so I'm really interacting with you and speaking with you, and that is my primary activity. The rest of it is all background threads. For that reason, programming languages, by and large, are oriented towards synchronous blocking code. Okay. So because of that reason, you really should be very cautious about approaching reactive programming. One answer, okay, that is a perfectly legitimate answer, and one that I've seen applied many times, is think about whether adding more complexity to your system is worth it, or whether you can simply solve the problem by adding more hardware and still having just a synchronous blocking machine that perhaps doesn't make as smart use of CPU and hardware. Okay? However, the reality is in some cases that may not be pragmatic. Right? You may have such processing volume and such resource ratios that you have no choice but to think about writing a more complex system that deals with these significantly more complex issues. Okay, let me stop there a second and let me give you a chance to sort of, I hope, absorb what I said and ask me questions back. Okay. All right. Fair enough. Okay, so reactive Java EE. What exactly does Java EE offer that is reactive? Well, this goes back to the statement that I made earlier, is that reactive programming is actually not necessarily all that new of a concept. As a result, because Java EE has been around for such a long time, it's already evolved to handle a lot of these use cases. And in fact, although by and large, so far, we've done this sort of subconsciously, at this point in time, we're actually beginning to do that consciously. We're consciously thinking about how do we solve this emerging problem. But actually, we've already gone quite far, as the gentleman pointed out to me. In all reality, we already have a very capable system that allows you to write fairly reactive applications. So I'll be going through what some of these features are. They're listed here in my sort of opening, if you will, my map for the rest of my talk. These are things like JNS, EJB3 message-driven beans and asynchronous session beans, CDI events, servlet asynchronous in I/O, JAX-RS asynchronous processing both on the client and the server, so WebSocket asynchronous remote endpoints, and then finally something else that was added in Java 7, namely the concurrency utilities for Java. This is just at a high level. There's actually a lot more that go along with the reactive programming paradigm in Java EE. Okay, so let's start with the most, I think the most foundational and most important API in terms of writing asynchronous event-driven applications in Java EE. In fact, the application that I wrote years ago, by and large, used JNS, nothing really much more than JNS and message-driven beans in order to write a highly reactive application. The reason this is because this is really, at the end of the day, what the goal of JMS is. Its goal is to provide you asynchronous processing in a highly reliable way. Right? So JMS is message and event driven. It's obviously almost by definition asynchronous. It gives you loose coupling. It is intended to be reliable out of the box. It also gives you things like transactions, durability, fault tolerance, error tolerance, clustering, all of those sort of other concerns that we talked about beyond the core concepts of what reactive programming is all about. Okay. On the other hand, whereas you have JMS as sort of a transport layer as well as an API layer largely to send and receive messages, you also even have an even more powerful mechanism to help you write reactive applications in JavaE, and that is message-driven beans. Okay? They essentially allow you to handle events, okay, in a highly transactional, thread-safe, pooled, reliable, load-balanced, fault-tolerant, and error-tolerant way. It's almost overkill. How much is actually done in a JMS message-driven bean. And again, it is in a typical JavaE style. A lot of these things, in fact, all of these things are done in a highly transparent fashion. They're done by the runtime without you even realizing it by default as to what is going on. Let's take a look at why through an example. Okay. So if you haven't looked at modern JMS of late, this is a modern JMS 2 API. Okay. It's a very, very powerful API. Really, it's just a few lines of code that does quite a bit of work. Okay. So in this case, I'm triggering off an event registration event handling handling event registration attempt, mouthful. And the way I'm doing this is that I'm injecting a JMS context object. This is a new object in JMS 2.2 representing pretty much the entire JMS API. I'm injecting the queue that I'm using for messaging. And then in a one-line statement, I'm sending this message out to the queue, the payload out to the queue. And by the way, I'm also doing far more than that. I'm also setting a whole bunch of time to live properties and optimization properties in that one line using a highly fluent API style. Okay? So in terms of event APIs, in how you can send an event in a reliable fashion, it's really tough to beat JMS. Similarly, it's tough to beat message-driven beans. So if you look back at this code, although you don't realize it, there's a lot going on here behind the scenes, things like acknowledgement and transactions as well. Okay, so this event isn't simply a naive thing in memory. Okay, this will participate in a transaction. This will have keep alive. This will have time to live. This will have acknowledgements. Similarly, you can get much more simple and powerful on the message receiving end than message-driven beans. Okay? So here's an example of a modern message-driven bean. This is all it really is. It's a POJO with an onMessage method, and then you simply annotate it to say, hey, I want to receive a message, from this queue or topic, and you can specify many other things that hopefully some of you are aware of. So a very robust mechanism for filtering messages, like message selectors. Again, things like acknowledgement modes. Again, things like retries. Again, things like transactions. Okay? So all of this is happening again in a very reliable and consistent way. And we can improve upon this even further in JMS 2.1. So we can most certainly clean up the syntax, okay, compared to this, and make it a bit more type safe. But we could do even more. We could add even more power to message-driven beans by doing, for example, things like allowing you to receive messages in batches. Okay, include the concepts of retries, delivering retry delays, ordering, and so on and so forth. Okay, so this only gets better, and this is the basic foundation of being able to send and receive messages. Okay. Now let's stop for a second and say that okay, you have a requirement to send and receive messages, but you don't actually need that much reliability. Okay? In particular, let's say you don't need persistence. Okay? Do you have options? The answer is yes, you do in JavaE, and it doesn't get very much simpler than EJB asynchronous session beans. I'll show you how that looks like in just a second. It really just, believe it or not, is an annotation on a POJO. Okay? And with that annotation on a POJO, you still get some guarantees of reliability even in an asynchronous system. You get transactionality, you get thread safety, you get pooling. What you don't get, that you usually get out of JMS, is that this is not loosely coupled, and we'll see that in a second when we take a look at the code example. It is not persistent, meaning that the message, if your machine fails, okay, in flight when you're delivering or processing the message, the message gets lost. It's not fault tolerant in the sense that if you fail to process the message isn't re-delivered. That is done in JMS. And it's also not error tolerant. Okay? So if you have an error, you need to handle the error yourself. There's no systematic, there's no runtime level error tolerance built in for you. But it's incredibly simple. All right, so this is all you need to do. Let's say you have a process payment method. You receive a payment. It's a long-running operation. You don't want to hold up your current thread. You want to make maximal use of your CPU by pushing this off into another thread, another background thread. Well, what do you do in JavaOne? It's very simple. You just throw in the @asynchronous annotation on it, and that's it. Okay, for the fire and forget case, for cases where you don't care about the outcome of what happened after the asynchronous processing occurs, this is all you need to do. Okay. Now let's assume for a second that that's not the case. Let's assume that you actually do care about the outcome. Okay, so let's take another example of you're generating a report. It's potentially a pretty long-running report, and in the end, you do care about the report back. Well, you can still do it. Okay? You can still do it in a very declarative, very simple way, again, by just throwing in the @asynchronous annotation on it, and wrapping the return type with the future object. Okay? And other than this, your code still looks very much just vanilla synchronous blocking code, although this is completely asynchronous code. Okay? The only trick again is that instead of returning the actual return type, you will be wrapping it into a utility object called async result. Okay? And whether you'll do that, whether you're actually you succeed in your processing outcome or not. Okay? Again, very few platforms can say this, that they have asynchronous processing capabilities in such a compact, powerful fashion. Pardon? How do you wait for the response? You simply get the future object handled back. Okay? And if you're familiar with Java util feature, it has methods like isComplete, okay, which is a polling method to tell you, hey, is the background thread complete or not? There's also capabilities of canceling the background thread. There's a cancel method, and that actually works in EJB3 asynchronous means. If you say future.cancel, it will actually cancel the asynchronous method. And there's also a blocking get call. Okay? So as soon as you say future.get, you actually will wait until you get the result back. You typically don't do that. Typically you do a check to see if it's complete, and if it is, then you do a future.get. However, let's get to that question in a second. That's actually an interesting question with regards to reactive programming. Yes, sir.
Do you have any control with annotations on the thread pool that this is run on, or is that implementation specific?
What thread pool does this run on? No. So EJB asynchronous session beans are generally serviced from the EJB pool. Okay. You can tune the EJB pool itself. So you could say, hey, for this report generation service, please make sure this is pooled to be such so and so. Okay. So make sure that the maximum number of asynchronous processes are handled by report generation service. This bean is, let's say, 10. So you can configure that.
And is there a way to have multiple pools? Like if I want to run a certain class, certain reports on one pool, but I don't want them ever to interfere with another report that I want to run in another pool. I don't want them to compete.
Okay, so there is a mechanism to do that. That's beyond obviously there's no simple way to do that in this very simple mechanism, but there is another mechanism to do that. Well, let's revisit that in a second. Actually, I'll give you a clue right now. It's called the executor service. Okay, yeah, it's part of the JavaOne concurrency utilities. We'll talk about that in a second. Okay, any other questions on this? Okay, moving on. Okay, now let's go farther down the simplicity route, and let's assume for a second that you actually don't even care about asynchrony now. Okay? All you really care about is event semantics. Okay? So all you want is basically a loose coupling, okay? And perhaps some mechanism of filtering and chaining, but really nothing much else. Okay? You don't even care about asynchrony at this stage? Do you have an answer for that in terms of doing event-driven development in Java EE? Well, the answer is yes. There is a very, very even more elegant, perhaps even more elegant than EJB asynchronous session beans. There's another mechanism called CDI events and observers. Okay? When you look at it, it's really nothing much more than a formalized implementation of the gang of 4 pattern, the gang of 4 observer pattern in a DI framework. Now, I'll also tell you in the end that although today you can do asynchronous programming in CDI using the CDI event bus, in CDI 2.0 you actually will be able to do that. So when that happens, it will be very equivalent whether you should use EJB session beans or CDI events. So it will sort of be a toss-up which one you should use. Okay. But anyway, let's take a look at that. So you should start at the bottom here with the annotation cargo inspector. This is a CDI qualifier if you haven't seen this before. This is a marker interface that we will use to sort of identify our event, okay, that we're going to send and receive. Next up, you'll see that there's an on-cargo inspected method that has this observer and observes annotation. And it takes a payload as an argument, it takes cargo as an argument, and it has that marker qualifier annotation on it, cargo inspected. So this is, again, all you need to write a basic event handling code in Java EE. It's just the @observes annotation, put that on a POJO, that's it. Okay? Now, the way you trigger this, okay, is you inject an event object. It's a CDI object. You give it the cargo parameter or whatever your event parameter, actual event payload is, and then when you at the point where you actually want the event fired, okay, you can call that event type dot fire and give it the payload. Okay, and the even more powerful thing about this is this can be one-to-many. JMS also can be one-to-many. EJB asynchronous session means is one-to-one. If you're making an invocation, that's going to a single EJB instance invocation. In JMS, you can make it one-to-many by having a topic. Okay, so when you fire off a JMS message to a topic, that can have multiple subscribers. Well, in this case, you can have either two. You can have one-to-many relationships here as well. Okay? You can have multiple observers listening to the same event and reacting to exactly the same event. Okay? And again, today this is synchronous blocking, rather not synchronous. But today this is blocking. It happens in the same thread. The event firing and the event invocation. In CDI 2.0, this will be made asynchronous as well. Okay. Right, moving forward. Next, we're going to move one tier up into the web tier. And a good place to start here is obviously the servlet API. Okay? And servlets actually today have support for both asynchronous and NIO. They are very close to even the most pedantic definition of reactive programming. Okay? There will be another concept beyond asynchronous processing and NIO that will potentially be added to servlets, and that's called reactive streams. I won't talk too much about this today, but it's yet another sort of emerging thing under the reactive moniker. For me, this really looks a bit like marketing. It has nothing much to do with the existing ideas of what reactive is, and it has a reactive sort of tagline and marketing buzzword to it. But even then, in Servlet 4, we are evaluating even adding support for that as well as part of the HTTP 2.0 world that we're doing. Okay, but more on current state. This is how asynchrony is handled at the server layer. The API is a bit different from a normal synchronous blocking servlet. So let's work through this if you want. So let's go back to our example of generating that long-running report. Okay. So you have an inbound HTTP request, and you're going to process this on a thread other than the inbound HTTP thread. Okay, you want to return the HTTP thread right away, and you want to process this in another thread to maximize the CPU usage on your machine, as well as to make better use of your HTTP thread pool. How do you do this? Well, you're still going to have the @WebServlet annotation. You're still going to give it a URL pattern where it is bound. How do you invoke this report? However, you have to give it a specialized marker called async supported equal true. The reason for this is that the programming model for asynchronous servlets is a lot different, and it's especially handled behind the scenes very differently as compared with synchronous blocking servlets. Okay, and let's understand why when we take a look at the method implementation of the do-get method. So we have the HTTP request, HTTP response coming in. The first thing that we need to do in order to start asynchronous processing is actually get a handle to this thing called an async context. And I'll explain the mechanics of async context in just a second. But we get a handle to the async context. And then what you do is you create your background thread. And you start putting your workload into your background thread. There happens to be a convenience method in the async context itself that allows it to do that. It's called async context.start. If you invoke this, it takes a runnable as a parameter, okay, and it spawns a new background thread in which you can give it your payload. Now, hopefully everyone is familiar with this funky syntax that I have on my slide. What is it called? That is good. Excellent. Okay. So instead of actually creating a runnable object, I'm creating a lambda here, which is actually an enabler to do things like asynchronous programming. It makes the asynchronous programming a lot simpler. You can see that in action here. Okay, so although this is asynchronous code, it looks almost like synchronous blocking code. It just looks like we've taken a block of synchronous blocking code and just put a wrapper around it and making it asynchronous. So this is, I would say, the goal of lambdas in this case is very much a success, especially in the cases of writing sort of very reactive applications in Java EE. Okay, so what are we doing in the background thread? We are getting the request parameters. We're getting that from the async context.get request. I'll explain why this is and why we can't simply get a handle to the original HTTP servlet request and do it from there. But bear with me for a second. So we get the request from there. We generate the long-running report. Okay, we print the report out, okay, again to the async context. And then when we're done, we hit the async context.complete method. Now this code bears a bit of explanation because it's not necessarily that trivial. Okay. Let's take a careful look at this code. And can you guess when the do-get method returns? Pardon? No, the do-get method returns as soon as I call async context.start. Okay, so in a traditional servlet, the inbound connection, okay, the HTTP connection, is closed as soon as I return from do-get. Okay, but that's not going to work in our case, will it? Because even though we're returning the request, the HTTP thread back to the pool, we still want the connection around because we're not done with it. Okay? So how do you do this? The way you do this is through that async supported marker. What we're really saying is please decouple, okay, the request thread from the HTTP handler. Sorry, the request thread from the actual connection. Okay. So this is really what happens is although the thread is returned back to the HTTP thread pool, we're holding off to the connection. Now the question is where are we keeping the connection and how do we get it back? Okay? And your answer is that is your handle. The async context object is your handle. Okay? It has a way of getting your connection back. The connection will typically be passivated, okay? but still kept alive, but passivated. activated in memory somewhere to reduce memory footprint. When you need it back, okay, in our case, when we're done generating the report, okay, you will simply call something like async context.get request or async context.get response and handle the request and response there. Okay, that will bring your connection back from the dead. Okay, and the connection will finally be closed when you invoke the async context.complete method, not until then. Right. Yes, sir.
What's the motivation for using a background thread versus a subject thread, particularly in a cloud environment?
The big question goes to the other gentleman that asked the question about worker thread payloads. Okay, so the application server has a number of thread pools. Okay, each of these thread pools are not equivalent. They're not all thread pools are created equal. Different thread pools in the application server are designed for different purposes. Right, so the HTTP thread pool is geared towards short-lived requests. And there's more of them. Right? So the idea, there's less of them, right? So it's a small number of threads handling quick turnarounds, right? 30 seconds done, 30 seconds done. So you can handle it with less threads. When you typically invoke something like a background thread, like you are now, its expectations and configurations and management is very, very different. So these are, the HTTP threads are usually high priority. These are going to be lower priority threads. There's going to be more of them, and they're going to be expected to be more longer lived.
I think my question is what value it provides in the cloud environment, which is more elastic, right? So the load balancer kind of distributes the load.
But at the end of the day, the basic, yes, it's on the cloud, but the cloud is also running on hardware. At the end of the day, even in a cloud environment, you need to be thinking about optimizing your hardware load. Your hardware, even in a cloud environment, doesn't come for free, right? No one's going to allocate another instance for you in an adaptive fashion and not charge you for it, right? So you still need to be cognizant of how you can make maximal use of your hardware even there. Right? Okay. Yes, sir.
The client is still waiting for the response.
The client is still waiting for the response. Not necessarily.
What am I saving exactly? Just that one thread you put back in the pool so we can process a lot more?
Yes. So principally that is what you're saving, and it's not necessarily that trivial, because if you have a scenario where not all of your requests are long-lived, right? You have maybe the odd inbound long-running thread on a machine that otherwise handles short bursts of requests. Well, what if you suddenly get a whole bunch of long-lived requests? You're going to lock up your HTTP thread pool for no good reason. So it's not a trivial matter. It's actually a pretty serious optimization to think about. As I said, usually you'll be surprised as to how small the HTTP thread pool actually is. Usually it's somewhere between 10 and 15. And the way you can get away with that is because it's such a short-lived request. Okay. Yes, sir.
So this type of implementation
This is server 3.2. Yes.
So
Sorry, I didn't mention
this really not complex with the Node.js implementation.
Node.js deals with asynchrony very differently. So their basic assumption is that they will never block, which is a strange assumption. That's very hard to accomplish in Java. So in JavaE, we don't make that assumption. If you want to make JavaE non-blocking, you can. Okay, in fact, the next feature I'll be talking about is going to be how do you make this thing in I/O. But in JavaE, we don't make that assumption. We make the assumption that your code may be blocking or non-blocking. We need to handle either situations.
One more follow-up question. So here this basic start happened. That's where you created a regular started the thread, right? So you could have responded back to the non status.
No. That's the whole point of the async supported equal true flag. Okay, so no, it's not returning any status
So
whatsoever.
it's still parked within the update server, and whenever the async complete happens, that's when the
let me direct your attention back to the print report method. Okay, so here you have print report async context. So you might think that a very naive, what would a very naive implementation do in this case? It would simply say, HTTP async context dot get response and get output stream and then write to the output stream. Right? The problem with doing that is, let's assume that this report is quite large. Let's say, by quite large I mean, let's say something in the order of 100 megabytes or more. Okay? And you're dealing with a lot of clients over a unreliable network. Okay? So what may happen is that although you do have this running in a background thread, like you should, it's assumed to be a long-running thread. There's a whole bunch of them, so you won't run out of them too quickly. Regardless, what may happen is that you may block on that call, okay, because of a slow network connection and because of the amount of data that you are needing to write. So again, you're winding up wasting a thread, right? And that's doing nothing but just sitting there being blocked. So in reality, what you would want to do, if you have this scenario, is you would want to do even the write in an asynchronous fashion. And Servlet actually will allow you to do so. There's NIO capabilities built into Servlet 3.1 as well, okay, Java 7. So this is how you do that. Here's the basic fundamentals of it. You get the Servlet output stream, by getting context.getResponse.get output stream. Then instead of writing to that, what you do is that you create something called a write listener. And you attach that write listener to the output. Notice that this invocation will terminate, okay, right after you call the set write listener method. So you're done with the background thread. Okay, the background thread is at this point finished. It is going to be returned back to the thread. So the question is, what is the fate of your write? Well, the fate of your write is in the hands of the write listener. This is how you implement it. Basically, it's an interface. You implement the interface. It actually just has a few methods to it. In this beginning part of this code, all I'm doing is I'm saving off a few of the values that I need, namely the Servlet output stream, the actual report that I need to generate, and the async context. The more important and interesting code is in the two callback methods of write listener. It has two different callbacks. One is on write possible, and the other is on error. So what exactly is on write possible? Okay, so here's an interesting question. So what happens in an NIO environment is that you actually wait for the stream to act. Okay? So on the on write possible callback happens when the stream says, I am ready to write. Right? So when that happens, you should begin writing, but you shouldn't write everything that you have, because at the end of the day, you may block if you try to write too much. So the basic technique you will use in NIO is that you will write in chunks. In my case, I'm writing in chunks of 256 bytes each, okay, very small chunks. And all I'm doing here, if you look at the code a little bit, is that I'm reading through chunk by chunk, okay, and writing out chunk by chunk my output. In addition to that, I also have yet another check call called output.isReady. So what this means is, each time I write, I am asking the stream again, are you still ready for me to write more? Okay? If the stream is no longer ready, then I terminate this while loop. Okay? And then I exit that, and I wait for the next callback of on write possible. And I do this until I'm finally done. Okay? I have nothing more to read, and only then can I call context. Okay. Asynchronous JAX-RS. Again, JAX-RS has asynchronous capabilities built into it as well. It has asynchronous capabilities both in the client and the server side. The syntax is very similar to servlets, except a little bit nicer. Okay. Now the bad news is JAX-RS still doesn't have NIO. Okay. So you may run into that situation of you're creating a background good news is, even that is coming in Java 8. In Java 8, they're looking to introduce NIO at the JavaScript layer as well. The code actually will look relatively familiar because it's conceptually very similar to how servlets work. Okay? So what you do here is that you have a endpoint, called generate report. It takes whatever parameters that you need. It takes this magic little parameter called async response, and that is similar to the async context in servlet. Whenever you have this method signature, it is essentially assumed that you want to decouple the request connection association. Okay? And then something else that I'm doing is that I'm combining JavaScript with EJB async. Okay? So I have the add asynchronous annotation right there, which means as soon as I finish invoking the generate report method, this thread, the inbound HTTP request thread, will be returned back, and we'll start a background thread to do our work. Again, relatively more simple. You do whatever it is that you need to do, your long-running processing, and then when you are done, you simply call response.easy, and that's how the connection is finally, the background connection is finally terminated. There are similar capabilities built into the client side as well. It's just as simple as similar to your synchronous blocking code in your JavaScript client. You just put in an async builder path to it. Okay? As soon as you say async, you have two ways of handling asynchronous processing. You can either get a future back, and process that future, or you can use a callback style as well. If there is time, we'll talk about both of these styles in a second. But there's two different options of doing asynchronous processing, either futures or callbacks. Yes, sir.
Does the recipe solve these things, or can I use any other CI scope there? Like you use async, JavaScript.
You have to use an EJB, or use some other mechanism. Okay, moving on. I'm going to skip over asynchronous WebSocket because we're running a little bit short of time. Okay, I'm going to, by and large, actually also skip over Java EE concurrency utilities because I want to get to something a little bit more important. Okay, but let me show you the basics of what the Java EE concurrency utilities is all about. So you have all of these nice facilities to do asynchronous processing in Java EE, right? Servlet async, EJB async, and the like. But let's say for some reason you still want to do low-level processing using the thread API, the Java SE thread API. You can't do that in a reliable fashion in Java EE unless you use something called a managed executor service. Okay? And how do you do that? It's really very simple. You inject a managed executor service, and then instead of spawning the thread yourself, you simply submit that thread to the executor service. I'm doing that via the executor.execute method there. Okay? Again, it's taking a runnable as an argument, and the container will safely and reliably start a background thread for me. And this goes to the question that the other gentleman had before. Okay? So the executor service that you can use, there's a default one, that the application server provides. It sort of makes default assumptions that background threads usually have. Again, long-lived, there's a few more of them around. They're usually lower priority and the like. However, you can actually create custom executor services. You can configure a custom executor service and make it whatever it is that you want. You can specify how many threads should be in this pool, what should be its priority, what should be its behavioral characteristics and the like. Okay? So this is another very powerful facility. All right. I have about 8 minutes left. I think that's enough time for me to cover what I'm going to cover next. If I'm not able to fully cover it, I encourage you to take a look at my slide deck later. So, and this is Java SE completable future. The best way of explaining this is through an example. All right. So let's take a look at this code example real quick. It is calculating, underwriting data for a given insurer. Okay, so I have a person P. I'm getting the assets for this person, getting the liabilities, calculating the credit score via the assets and liabilities. I'm also getting the person's health history. I'm calculating their health score, and then finally, based on the credit history and the health score, I'm determining how much coverage this individual should have. This code looks innocent enough, but it can actually be a serious bottleneck in your system. Okay? Because each of these calls, get assets, get liabilities, calculate credit score, can be either blocking I/O calls or extremely CPU intensive calls. Okay? So you cannot have this method be disnied. It has to be another way of handling this code. So one way of doing this is to use the executor service that we talked about. So we're going to basically wrap up all of our potentially time-consuming calls in background threads of their each of their own. Okay, so get assets, get liabilities, everything is being done asynchronously, and then I'm doing a bunch of get calls. Okay, where I need the results back, I'm doing get calls to handle the next step in my processing. I want you to take a look at this code real quick, and especially pay attention to the comments that I have. Okay? So I've certainly improved a little bit, whereas the code previously was all done in a synchronous blocking fashion. This code is being done at least ostensibly in an asynchronous fashion. We're throwing more threads at the problem. The problem is everything until executor.submit and then calculate credit score is fine. Okay, so I'm getting the previous two values that I need for this calculation and executing that calculation. That calculation is also being executed in an asynchronous fashion. The problem comes in the next call. Okay, so notice that because I have f1.get and f2.get, nothing will proceed until both f1.get and f2.get are complete. Okay, which means we will actually not reach this next call that gets the health history until both f1 and f2 are done. But in all reality, we don't need to be held up there. Okay, so we're making, again, not maximal use of our threads. Okay, and the reason this is happening is because futures are a blocking call. Okay? So how can you solve this problem? One way of solving this problem is using callbacks. Okay, and I won't go through this code, but I invite you to take a look at what happens when you do that. So I rewrote this code using callbacks, and that will make this entire code completely non-blocking. However, it introduces another problem called callback hell. Namely that although this code looks complex, the callback handling code will look even more exponentially complex. Okay? So do we have a solution to these problems? And the answer in Java SE 8 is that yes, we do. There's something called completable features that will help us out. So in order to introduce what completable features are and why they're important, I've essentially refactored our previous example of processing the payment and refactored it to use completable features instead of Java util feature. So the basic difference between feature and completable feature is that completable feature is non-blocking. Whereas feature.get is blocking, there is no such feature.get call. What you do instead is then you call something called then accept. And that is a callback. Okay, it's a callback built into the completable feature API itself. All right. So what happens here is that in my client code, I create a completable feature object. I return the completable feature right away. All right. So the client has a handle to it right away, and they can go ahead and register the then accept callback as soon as they receive the completable feature in the code below. But after that, what happens happens is we don't actually do anything with this until we're done doing whatever long running processing that we are going to do, and in the end call future.complete and give it the actual return type. And that results in a callback, okay, to the registered method that the client has. So the confirmation.system.built-in confirmation will be invoked by my background thread output. Okay? So all of this code is essentially non-blocking. The other thing that completable feature also gives you is composability. And I won't go through this code too much because I'm really out of time. But if you go through this code in the slide deck, what you will realize is that you're doing exactly what you were doing before, okay? But this code is completely non-blocking. Okay? Certainly compared to the naive code, and even compared to the asynchronous executor service code as well. Right? And it's relatively clean. It's as clean as you're going to get with this style of programming. Okay, let me skip this over. Basically, the long short of this is there's a few other areas where we could improve reactive programming support in JavaE. The biggest one really is at the database layer, at the JPA layer, making that layer more reactive. However, again, we are actively looking to see what else we can do to make JavaE a much more reactive platform. Okay. So just to wrap up, reactive programming, it's a relatively well-established technique. It may become more important in the future, and some of you may have use cases for it already. JavaE already has a whole bunch of reactive features built into it. You can go a long way towards designing these sort of applications in JavaE today. You could improve upon this even further in JavaE 8, and Java SE8 helps quite a bit. Okay, so it helps with things like completable future that we've adopted to some degree, and we can adopt even more in the future. Maybe there is even more that we haven't even thought of yet, and we'll keep a look at. We'll keep looking at the ecosystem to see what else we can do. In the end, though, do be careful. However you slice it and dice it, hopefully this presentation gives you a flavor of what you'll be dealing with if you start writing these sorts of applications. So don't do it too much. Do it if you really, really need to. All right. So without further ado, let me tell you where you can find this slide deck. Okay, so there it is. All right. It's a fairly simple URL, simply slideshare.net/reza_rahman/reactive-javae. Okay. All right. That's it in terms of everything that I had to say. I think we can take some Q&A. We have officially 1 more minute. We can take some Q&A before we need to leave the room. Yes, sir. Yes, I can bring up the resources slide. There it is. Yes, sir.
Was that for this current version of the GPA?
No, that's something we need to build in the future. Yes. Yes, sir.
How does the calls integrate together with the CDI context? Do I have the same CDI context available in the thread?
You're talking about asynchronous CDI events?
No, I mean, in the servlet, I have a request context, a CDI context, and then I call some thread.
Is that a separate CDI context? Yes, it is. That's going to be not in the current request scope. That's probably going to be an undefined CDI scope. Yeah, unless you inject some kind of other CDI management in there. Because when you're saying excuse me, when you're saying async context.start, you're really giving it a block of code. It's a runnable. Okay. If you're using an executor service to execute that, that is basically in an undefined CDI scope as well. So you'll have to inject something like an application scope bean if you want to handle it that way. So you can give it an application scope bean and invoke the application scope bean, and that way it will be an application scope or dependent scope, whatever you want. way would be to stick it in an application scope bean, or an EGB singleton bean, or in a distributed cache if you need it to be available across your cluster. Yes, sir.
One question, back to the frameworks which are already there, like Node.js. So would this do almost the same as Node.js Unity?
Yes, as long as you write your application that way.
Okay.
Yeah.
Thank you.
Okay, very good. Thank you.
Good afternoon, everyone. Thank you for coming to the last batch of sessions at JavaOne. My name is Bruno Borges. I work for Oracle as product manager. And just waiting for the slides to come up. I work on the Oracle Cloud team. There you go. Thanks. I work on the Oracle Cloud team on the outbound product management team. So my job is to make sure customers, developers, operators, admins, they understand what is Oracle Cloud Platform as a service and how you can use it. But I also work as, on my free time as an evangelist, as someone that engages with the community and also with the Java EE platform and other frameworks, not just Java EE. And for the past 3 years, I was working as regional outbound PM in Latin America for WebLogic. And at that time, it was great to work with WebLogic directly. David, you are welcome to join the stage here and set up your laptop. David Cabelos will be co-speaking with me. He's a inbound product manager for WebLogic. So David is the one who actually talks to the engineers and makes sure the features of WebLogic that customers are most interested about are implemented, hopefully the right way. So we're going to be talking here about Java EE application servers. Before that, of course, safe harbor statement, we're going to be covering some features on products. That's why it's important you understand this statement here. So Java EE application servers, containerized and multi-tenant. There's a huge hype on Docker. And of course, last year I decided to work on Docker support for WebLogic, and working with the inbound team, Monica Riccielli, David Lyons, the inbound team, we put together a support and certification for WebLogic on Docker. And then WebLogic decided to implement a new feature called multi-tenancy on the application server level. And then you ask yourself, so should I put WebLogic on Docker or should I use multi-tenancy? Should I use both? Should I just use WebLogic the usual way? And that actually is interesting because the multi-tenancy idea is, it is like Docker but reversed, right? It's weird to explain. So what are we gonna do here? I'll go cover a few slides and I'll show you a demo on Docker. And then with the help of David, we're gonna understand how the multi-tenancy of WebLogic works on, for application server. So, of course, as the traditional Java EE application server environment, what you have is, usually you're gonna use the application server either as standalone or with a domain model. You can have the standalone, you're gonna see Tomcat, not exactly an application server, but you can add lots of stuff. You can use Tom EE. You can use Wildfly on standalone mode, JBoss, the versions before, all standalone. But some application servers offer a domain model where you can organize lots of resources on your application server and deploy applications the way you want. And still resources can be shared among those applications. So on the standalone mode, you're gonna see one application instance with applications deployed, JMS, data sources, all that deployed on that application server. Of course, even on the standalone mode, you can create a cluster. But with a domain model, you can actually have different clusters managed by that same domain, by that same application server. And then you can define a bunch of applications, JMS resources, data source, security realm, a bunch of stuff, and you can say, hey, I want to put this application on this cluster here, and that other application on that other cluster. And you can spin off different machines. You can do a really cool topology, domain model based on your application server. And this model has been on WebLogic since what, 2000, the domain model of WebLogic, how old is that?
It goes back at least to WebLogic Server 6.1.
6.1, so that's like
99?
99, yeah. So it is a model very stable. Everyone knows. People use it for many, many years. But then we got Docker, we got containers, we got isolation, that we want to isolate the memory, we want to isolate the CPU, the resources. In this domain here, in this example, in this picture, usually the JMS resources, the data sources, they will be available on the GNDI tree to all the applications. So you don't have a lot of isolation. So what customers, the administrators of these environments, they end up doing is they spin off new domains. And then you start to have different domains, and you have to administer that, and it becomes a problem. And then you're gonna see companies like GM, who has like 10,000 of WebLogic domains to manage. And then that's why some customers go to Enterprise Manager. They can manage all that infrastructure. But then we see Docker. And last year, we certified WebLogic on Docker. Between last year and this year, I don't remember exactly when, we certified WebLogic 12.1.3 on Docker. So actually, you can now run WebLogic on Docker containers in production. And we certify some topologies on that. So how does a Java EE application server works on a container? You may have seen sessions by Arun Gupta or by other Java EE evangelists running Java EE servers on Docker containers, but you don't see clustering, you don't see load balancing with a failover of transactions, EJBs, that kind of thing. So what happens is you're actually just using the Java EE platform as an API that is ready to be used, but you're not taking advantage of the full Java EE application server, all its features available, HA, clustering, replication, distributed JMS, all that. So that was the problem at the beginning when we thought, oh, can I put the Java EE application server on a container? Yes, you can, but it's standalone. So this is the certification, the new certification we released. Now we also have 12.2.1, which is Java EE 7 certified and runs on Oracle JDK 8. And it's only 8 because 8 is awesome. We have Lambda expressions and stuff. The Docker version is important, 1.7 up. We suggest you always be on the latest version of Docker. In that project, they release something new every month or so. So what kind of topologies we have with WebLogic on Docker, on containers? You might end up with 2 topologies at the moment that we certify. You might make it work. You might be able to make work some other topologies, but you cannot certify those. So number 1 is the single host clustered configuration. You can actually have a clustered environment on containers on a single host machine. Or you can have standalone instances of the admin server inside a container and then spread across multiple hosts. The difference between one and the other is that on a single host environment, when you have a cluster, it is a real cluster. So you are running the containers like a lightweight VM. So you're saving resources on that. Now, you might think, why should I do that? Well, for the developers to replicate a production-like environment on their machines, they would have to start at least 2 virtual boxes to actually have some idea of a production-like environment. With the containers, it's much easier. And you can share that among developers. Instead of downloading a VM with like 10 gigabytes of memory, you just share a container image with all the domain configured to deploy applications. And you can create servers and test some clustering on that environment. But if you want something more like the Docker way of doing stuff, you're gonna use the multi-host configuration with standalone admin servers. So that means you put all your applications, JMS stuff on a domain. You just fire the admin server, you target the applications, all those resources to the admin server, and then you run the admin server as your platform, runtime platform for your Java EE applications. And then you can, of course, have a load balancer. So how does it look like when you start Java EE application servers on containers? You're gonna have the admin server, we're gonna start WebLogic, and then you're gonna call a script that you offer that helps that. It's called create server. The create server script, that is on GitHub, by the way, you can call WebLogic scripting tools and define your domain the way you want. In the case we have on GitHub, it will create a machine and it will create a managed server and associate that automatically to the domain running on the admin server. And then you can fire that command multiple times, and then you have more containers with node manager and managed server running inside each container. And from here, you can go to the admin console and say, hey, I want to create a cluster now with these servers. But all that on single host. Now, why on single host? Because Docker does not offer networking between containers on multiple hosts out of the box. There are many solutions out there, but none are stable, none actually work, and Docker is still working on that. There is an experimental feature on 1.8, but again, we cannot certify an experiment from the open source project. It has to be stable on an actual release. And then in front of that, you can, of course, use a load balancer. Now, on the containerized mode, it's pretty cool because you just have this image with all your application, all your stuff deployed to this domain, and then you can fire many containers for that application. So you're gonna have on your host, you're gonna say run, start WebLogic, and then you're gonna say run, start WebLogic, and say run, my application, start WebLogic. You have 3 instances of the same image. That means you have 3 JVMs running admin server with the same application, all the JMS resources. And that's why you can just put load balance in front. What you don't have here, failover. Because if a user is connected to this server and that container crashes, you're gonna lose that. Because there is no clustering. But if you want to start other applications, just go there and say my WebLogic app 1, and then you have a new container running from a different image. Since the containers don't have communication between each other, these applications, they can run on different hosts because there's no failover. There's no communication between the managed servers. You cannot have transaction being restored on the second server. It all happens in there. So you can have the same containers, but in different hosts. And then you can go to host 1, 2, and 3 and fire the containers, and then you can have load balancing. Now it's odd because for many years, we've been documenting to WebLogic users, do not put stuff on the admin server. And now we are saying, well, now you can put stuff on the admin server as long as you run on this way here, on a container. And that should work fine. Now, how about the data? Where do you store the data? Now, this is important. The Java application server, it has a bunch of information, binaries, logs, patches. You're going to patch stuff. Where are you going to host that? Should I access the container runtime and patch it? No. What you're going to do is you're going to either patch the image and shut down the container, the old one, and start a new one with the patched WebLogic, or you're going to store the binaries on somewhere else, and then you patch that, and then you can maybe restart the container that will grab the new binaries, the patched binaries. So there are 3 ways that you can save data from the WebLogic running containers. You can have the container 0 here with my domain, your application, WebLogic binaries, everything inside the file system of the container. Now this is like you should really consider this like stateless, disposable container. Whatever happens, you just kill it and you start a new one. You patch the image and you just use the new image. But if you want to have files in some state, you can use 2 approaches. One is the data volume on a container. So you have your runtime on this container here, and a second container just holding your data, just holding your files. For example, WebLogic domain files. This means that you can take these containers and just shift them to a new physical server. It's more portable that way. The third way is the data volume on a host environment. That means all the files will be hosted on the file system of the host server. You have a better performance in terms of I/O if you do a lot of I/O in this case, but we don't think that would impact much. But still, the files will be hosted on the host server, and whenever you need to shift stuff, then you would have to copy those files to the physical server, map that folder again back to a new container. So they all have their pros and cons. So what about the issues? Yeah. I'm sorry?
The data disappears when container dies.
No, you can have access to the container. The file system is there, but when it's shut down, then you cannot get. I think there is a way to get access to it. I might be wrong. No, the data stays on the container instance. So when you do Docker PS, you're gonna see the containers in there, even the queued ones. So you're gonna still have access. This data volume and container approach is actually designed. You're gonna check that on the Docker documentation. That's a pattern that they suggest. So the issues that we found during the certification process was, one, the IP address changes when you restart the container. So that is quite problematic for a clustered environment. You have the servers configured with their IP addresses, and you restart the admin server, and the managed servers cannot find anymore the admin server because the IP address changed. And that happens vice versa. So the managed server restarts, the cluster doesn't know anymore where the managed server is. So that's a big problem for a clustered environment because of the IP change thing. There are solutions for DNS. You can run a DNS server, but there might still have some problems because sometimes the process does a naming resolution, caches the IP address, and does not check the resolution anymore later. It depends on the whatever you're running inside. And the multicast support, only in unicast, so you cannot do multicast between the containers. Now, on the future, like future roadmap for Docker and WebLogic, the things that we want to take advantage for running the application server on this kind of environment is the multi-host support. So it would be easier to have a communication between the containers, between multi-hosts. And we could be able, for example, to create a virtual network, with all those containers from different hosts, but they think they're on the same network. The data volumes, so there's a new feature to manage the data inside containers. So all those two patterns there, they probably will be still practical, but it is better to use the feature they are working on, data volume management. And finally, the security. So there are two reasons we don't push the Docker image of WebLogic to GitHub, to Docker Hub. One is licensing, and the second one is security. We cannot sign images yet. There's no feature for that. So you cannot have certainty if the image you are downloading from Docker Hub is actually from Oracle. So that would mean you might end up with a WebLogic with some malicious code inside. So the feature is, of course, as long as they become available, publish the images on Docker Hub, some integration in Maven, optimize the size of the image, and some other products that the teams are already working on, SOA Suite, Enterprise Manager, database, all that on Docker. Now let me show you how does it work running the application server on the Docker container. So let's take a look at the terminal here. So I have some containers running, but they are all exited. So what I'm going to do is first I'm going to Docker RM these containers here. Okay, now I have a clean environment. I have some images. So I have my WebLogic image here. I have the installation image. So this is how you're going to use WebLogic on Docker. You're going to create the image of the WebLogic installation environment, which means JDK and WebLogic installed, but without a domain. To create a domain, you have to define your image that extends this image. If you go to the GitHub project, you can see that here. You go to samples, and then you can check the 12.1.3 domain. We already pushed the 12.2.1 domain, but I'm showing you 12.1.3. You're going to see the Docker file. And the Docker file extends from this image. This is the image that you should build when you check out the GitHub project. And then there are settings like admin password, what's the port number for the admin, what is the node manager port, what is the default managed server port, the JVM settings, stuff like that. And then finally, what is the default command? The default command will be start WebLogic. So what we can do here is Docker run -d my WebLogic image start WebLogic. And that gives me a container. So now let's inspect this container and find its IP address. So this is the IP address of this container. Now we can go to Firefox and say, hey, give me the container 1 and let's access WebLogic running. And then you have the admin server at least. And this is the same WebLogic as you know. Now we can come here to servers, and we can see that there's no other server, just the admin server, right? So for the containerized model, what you can do here is deploy applications on this WebLogic environment, and then you can take a snapshot of this container and say, hey, here's my containerized application with WebLogic configured and the application running. You just spin off new containers from that image. Or you can use WebLogic scripting tool and automate the build process to deploy shared libraries, create data sources, etc. So let's start new servers. Let's go to the Docker run again, and let's say Docker run, my WebLogic image, create server. Now create server is a shell script that will call a create machine server. There's another shell script that we published on GitHub as well. You can check out the code. But let's do the cool stuff. Server.sh. And then you have a new container running. Now, this container here, let's access it internally. Bash. So this container runs Node Manager, and it hasn't started yet, but it will also run the managed server. So let's see how we are. Or better not, let's do with sudo. I've been experimenting using Docker without root, but it has been working well. So let's remove the containers and start the admin again. So let's start the admin server here. Docker run, -d, my WebLogic image, start WebLogic. Okay, let's get the IP address. That's a new container, new admin server. Okay, got our WebLogic instance. And then let's start Docker run -ti. I'm gonna do this one differently. My WebLogic image, create server.sh. So let's gonna see what this script will do. So there's a lot of WebLogic scripting tool behind the scenes. We connect to the admin server. Oh no, host. Oh yeah, sorry about that. So there was a missing part here. So the admin server needs a name. So let's do Docker run -d, my --name, WS admin, and then -d for daemon, my WebLogic image, and then start WebLogic.sh. Okay, now we are good. And now I'm gonna use my script, or else I'm gonna screw up again the demonstration. So let's go to samples, 12.1.3, cat readme, and here's the command that I actually need to fire, this one. So I'm gonna give a host inside the second container with WebLogic admin pointing to the admin server running on the other container. Now we have the right setup. So we have this one running. And this is WebLogic. now we have the proper environment. So I'm sorry about that. So this is the machine that was added automatically running the container. So you see this is the same hash code of the container. The script, the WebLogic script, will use the host name, which by default is the hash. So I can do Docker inspect and get the container that is running. So this is the create server. So it's a machine run node manager and manage server. So what I can do is I can fire a new command and create a new container. And then I can do again and create a new container and so on. So what's gonna happen, I'm gonna have more machines added here as soon as the script is called. We have one managed server already. It's up and running on that container. We have a second machine now available from the second container that I created. It's reachable, and we have the second managed server up and running. And then from this point, you can create easily a cluster if you want. Or you can actually go beyond, and with some WebLogic scripting tool, you can actually do a dynamic clustering. You just fire up more containers and you make more machines / managed servers available as you want. This topology works fine. We support on single host environment because of the Docker limitation. And if you want the single host containerized application, that's pretty easy. You just go there and put everything. So if you want to check out the script code for those WebLogic scripting tool, you can go to 1213 domain side samples and check the container scripts, and that gives you an idea on what we do here. But again, you can do your own scripts. So they're actually pretty neat. They add servers using random code, like just some random name for it, add names, get the password from the environment, connects to the managed server, sets information from the managed server, stuff like that. So this is the approach for running WebLogic on containers, and that's how we do it, the certification. That's how you can run a Java application server as you would expect with a domain model, with clustering on containers. And hopefully in the future, we can do that on multi-host. Now, to talk about multi-tenant, I'll ask David to come up and cover the new stuff that we have for kind of doing the same thing in terms of isolation, because with Docker containers, you can isolate resources, but with multi-tenancy, you don't need the containers. You just need WebLogic installed. So thanks, David, for coming from OpenWorld here.
My pleasure, everybody. So 3 words, right? Portability, density, isolation. It's pretty similar to what you get out of using Docker, and that's actually what we built into WebLogic Server. So the idea is it's very similar. We're solving the same problems. We're just solving them at a slightly higher level. So my name is Dave Cabellis. I'm a product manager in the WebLogic Server group. We've spent about 2 years working through this set of features I'm going to talk about. And I'm going to talk about them and you're going to hear, like, wow, they solve a lot of the same problems. They might solve some additional problems. They might not solve some problems that Docker would solve. So there's lots of choices here, right? So that's part of what we're doing as a whole group is we want to make it so you can run, our products the way they solve your problems in the best way. Safe harbor statement. So this is kind of what I started with, right? Is microcontainer. This thing, it's a container within the app server. It gives me the ability to move things around, right? So microcontainer for portability. Density, right? So I'm going to run multiple of these things in a shared environment, in a shared WebLogic domain, a shared set of JVMs. And then the last thing is once I start putting these things together, I need isolation. Right, so and then there's a lot going on there. So I'm gonna peel back the onion just a little bit. This slide I'm showing just because I really like the graphic more than anything. It kind of shows the general idea. We're going to take applications that had their dedicated stack, and let's take the application, some pieces of the application that they need, and encapsulate that into this pluggable partition or microcontainer. We're using some terminology interchangeably there, but the idea is let's portability, density, isolation. So this is what it looks like when we start to think about how does it look like within a single JVM. So the gray box on the screen here is meant to indicate a single managed server, a single JVM, however you want to look at it. Within that single JVM, I've got two pluggable partitions running. Within each of those pluggable partitions, there's an application, might have multiple modules. It's got its own set of system resources set up, like a JMS configuration, data source configuration. Within that partition, there's also a dedicated naming service. So I think I've got a dedicated JNDI tree. What happens within that partition stays within that partition. It's kind of like Vegas, right? So when my application is looking for a resource, it's not going to look across and see something else. It's only going to see what's within this partition. We think about the addressing things. We talked about IP addresses changing and so forth. With these microcontainers in WebLogic Server, you actually define the addressing, how things are going to get to this partition in a thing we call a virtual target. It's a lot like a virtual host. You can give it a host name, you can give it a port, you can give it a URI prefix, a bunch of other things you can do there. But the idea is, how do I get to this application where it's running? And that remains consistent, right? So it's easy to keep this addressing. We've also built in integration into Oracle Traffic Director, which is a software load balancer. I think layer 7 software load balancer. So when you add one of these partitions into WebLogic Server, we automatically update the web tier to say, this is how you get to this thing. If you unplug one of these from one environment, plug it into another, we also update the web tier for you. So I think of it as a microcontainer gateway, right? It keeps track of where things are. With microservices, you think of an API gateway. Well, this is kind of the same idea, but my service is a little bit bigger than just an API. It's a service. And we just want to make that very easy to get to. Things don't change. Thinking about isolation, data isolation specifically, natural affinity with Oracle 12c database, pluggable databases. There's no need to run a pluggable database, but it just kind of makes sense, right? Try to get the best efficiency at all the different layers within this platform. But you can run NoSQL, you can run MySQL. We don't really care. It all works. And then, of course, there's an integration with coherence in this also. So if your application needs a coherence cache, we actually share the coherence cluster, but for each partition, we spin up a dedicated cache service. So that means, okay, I get best density, but I get the isolated data as well. So it's a pretty nice end-to-end story. You can focus on the middle tier. That's kind of where I live, but it's a nice end-to-end story. So what do these microcontainers give us, right? So portability, I kind of started with this. They are an encapsulation of that application plus the system resources that it needs. So it's not as big of a container as you would think of for Docker, right? It doesn't go all the way down to pieces of the operating system, does not include a JVM, does not include additional pieces of the app server, right? It's just the application and the stuff that the application needs to run in a Java EE environment, right? Then you can, so if you think, this picture shows the model might be, I get a zip file and a JSON file that goes with it. I then want to move that to user acceptance testing. I import that. During that import, it could be immutable, right? I can just use the way it is and import it that way. And then, or that JSON file exposes all of the different attributes that can be changed, right? It's configuration attributes for the partition itself, as well as for the stuff that's in the partition. Could be a different deployment plan, could be a different URL for the data source, which kind of makes sense. But so you get lots of options there, right? And then this becomes also a way to move to cloud, right? So if you're running, say you're running WebLogic and Amazon Web Services, maybe that's where you do your development, that's where you do your testing, right? It's easy to encapsulate this, move it to the cloud. Maybe from testing, you'll move it back on premise for production. Lots of flexibility there and lots of cloud enablement as part of this. So that's the portability factor. Sure, go ahead. No, so the question is, each partition will have its own admin servers? No, so what we're doing is we're actually sharing a WebLogic domain. So the domain has an admin server. In the domain, you can set up one or more managed servers. You can set up one or more clusters. And then you would share those clusters. So you'd have multiples of these partitions running in the same set of JVMs. So think, what I had before, I might have had a 2-node cluster dedicated to a single application. Now I might have a 2-node cluster and I'm going to run 5 applications in that. But within those, I've got isolation between them so they don't stomp on each other. And I'm going to talk about the isolation factors next. But so we're sharing the platform. The platform is the admins. Think of the domain as the shared, a WebLogic domain as the shared infrastructure. So isolation, so there are 4 flavors of isolation. I've already talked about the traffic and data isolation already. The next one, the top one, is the runtime isolation. So this is where we actually partnered with the Java JDK team. As we were designing this whole infrastructure, it became really clear from customer feedback more than anything that there was no way we were going to be able to put multiple applications together without providing some level of isolation for OS and JVM resources. So think heap, think CPU time. Open file descriptors was another one that came up as a really important piece here. So we partnered with the JVM team. The JVM keeps track of those 3 resources, right? Retained heap, CPU time, and open file descriptors for each of these pluggable partitions while they're running. And then at the WebLogic tier, we can set, or you as an administrator can set policies that say, okay, when this partition uses more than X amount of heap, take some action. And there are a couple of different actions we can take. One is we notify the administrators, we write to the server log, or we can slow down a partition. And the way we do that is we actually deprioritize all of the requests. So it's still a single shared request pool, single shared thread pool for WebLogic, right? It's all asynchronously handled. So for a particular partition, we actually slam on the brakes, right? We say, we're going to deprioritize by 90%. So we really slow things down. The idea is, okay, let's stop this partition from harming the other partitions running in the same JVM. The last action there would be a stop action itself. So within a JVM, I can stop one of these partitions. So if I got 5 of them, I would just stop the one partition. Would not affect anything else. Right, so that's runtime isolation. The next is security isolation. So for each of these pluggable partitions, you can have a separate security configuration, separate security realm. That means a different authentication provider, different authorization provider, different credential mapper, different set of users, right? So different, a completely different security configuration. Users also means administrators, which is kind of a nice segue to the administrative isolation. So I can have a different set of people. You can have administrators that are autonomously administering this pluggable partition. So I can come in, I can start it on its own, I can stop it on its own. I can change the configuration. I can deploy applications in it. It's all independent of each other. Right, so think administrative isolation. Why would people have dedicated a set of VMs before for this? Well, I need to update it at a certain time, or I need to start and stop independently. So that's all provided. And I've already talked about the traffic and data isolation. So I wanted to dig down. I actually have kind of gone through this a little bit talking, but I'll show you this on the screen. So this is this notion of the resource consumption managers. This is the partnership we had with we still have with the JVM team. And this is where you can set up these different triggers, right? So on this example, I'm showing a notify trigger at 1.25 gigabytes roughly. Roughly 1.5 gigabytes, we take a slow action, and at 2 gigabytes, we'd say, okay, that's enough. We're going to stop this one. I will tell you that this requires G1 garbage collection, and our internal benchmarking has been phenomenal with G1 garbage collection. So at a couple other sessions I had this week, had other people come up to me and say, we're using it now, and we're really getting good results with it. It seems to be really efficient in the way that it handles, especially young GC stuff, right? It's able to stay within its pause time goals and keep things running really well. Go ahead, question?
Is that limitation only on the memory side, or you do data at CPU level and things like that, what Salesforce does as a platform?
Right, so the question was, is this only on memory, or does it also CPU and other resources? Right, so we also do CPU time, so heap seems to be the one that everyone wants to know about, so that's what my slide talks about more than anything. But CPU time, we also keep track of per partition. And then the next one is open file descriptors. So that was one that, was sort of a little bit of a surprise to me, but we heard from administrators like, hey, this is, we see my apps run into this problem frequently, so if you can track that one for me too. We're looking at other things. We're looking at some additional analysis tools building into this. We're also looking at providing information in thread dumps and heap dumps, and also in flight recorder. So the events coming out of the JVM into flight recorder would also include right now it does include like a consumer ID, it's called, but we want to make it very clear what that is. You can map a consumer ID to a partition at the WebLogic layer. We want to take away the work there. Go ahead, question? So the question is, are each of these microcontainers completely isolated, or can they share some resources? The short answer is they're completely isolated. We actually looked at providing, say, a shared data source, and then be able to switch that data source to depending on what the context was, who was asking for the connection. We could switch to a different pluggable database. We found the performance of that was really not working out so well. So it's not off the table. We're still looking at that. But in general, it's these things are isolated. I'll tell you one other thing too that might be interesting related to that is class loading. So there's a single system class loader, but then there's a branch for each of these partitions. It's fully transparent to applications if you just deploy them. But if you have a situation where you want to run the same application multiple times, and you know you've got certain classes that are shareable, you can actually define them in a deployment descriptor as shareable, and then across your whole environment, you would only load them one time. So there's kind of rocket science stuff built in to say, yes, you can do some things that are pretty advanced. The easy stuff is easy though. It doesn't get it. It's, I'm deploying an application. There's nothing else I need to do here. That's great. From a density perspective, so what we're seeing is when we start to use this micro-container stuff, we start to say, now I'm going to put stuff together. What's the benefit? So if I take a pretty standard piece of hardware, an HP DL380, 16-core box with 256 gigabytes of RAM, I think I can run roughly 10 applications on that, and that's with oversubscribing with VMs on a 3 or 4 to 1 basis on the CPU. Heap, there's plenty of heap, but let's say 2 gigabyte heaps here. I've got four node clusters set up for each of these, so I'm running 10 individual domains. That's what's on the left side, right? So the big gray box is meant to be a server, right? Then on the right, I say let's put these into microcontainers. So I have 10 of these microcontainers running in a single domain. And then when we actually run this to see what happens, we're actually able to get 3 times the number of applications running on the same piece of hardware. All right, so even though I put 10 applications together, and so sometimes people talk about like a 10x consolidation. The real thing is under the covers, it's about a 2/3 savings in hardware. Your mileage will vary, I'm sure, based on what your application looks like, what it does, and so forth. But it's pretty significant. From a numbers perspective, it's kind of, I know it's a little bit of an eye chart, but the idea is that when we ran this stuff together, we saw 2.5 times less CPU usage, and then for a memory footprint, we saw 3.5 times less memory usage. And so we actually measured the footprint of the JVM on the operating system. So we didn't just look at heap. We actually went down and said, what is the footprint of the JVM on the operating system? And we went from about 1 gigabyte per each of those managed server VMs to almost 3 gigabytes for each of the managed server VMs, but I'm running 10 apps in them. So it's a pretty big difference. We also did, if you can look here, the first row that has any data, and it tells you our JVM settings. So in the separate test, we set our max heap at 2 gigabytes. In our combined test, we set our max gig at 2 gigabytes also. And we didn't see any reduction in throughput. We didn't see any reduction in response times. So as I pushed this further, when we got up to like 13, 14, 15, that's when we started to see reduction in throughput time, that sort of thing. Question? Right. It still runs for the whole JVM. So the question is there an independent garbage collection for each of these microcontainers? No. It's still a single JVM. It's still a single garbage collector. It's a very commonly asked question, and actually we've been talking with the JVM team saying, is there something we could do here? Is there some way we could actually do this? The problem is, in the regions where memory gets set up, a lot of times there's cross dependencies between those things. So for us to do a real garbage collection per partition, it's pretty challenging. So what we're seeing though with the G1 garbage collection, so I ran this for a couple of days, hitting it with constant load, and we didn't see a full garbage collection during that whole time, because the young GC really really behaves very well in G1 garbage collection. Now, like again, your mileage will vary, right? If you've got an application that grabs some memory, holds it for a very long time, then that's going to end up in something, what I call the old generation, and then that might trigger a garbage collection to get collected when you close that. So, but I've been like thrilled with this stuff. It's been really good. How are we doing time-wise? 5 minutes? Okay. Okay. So this is, I'm kind of at the end of the regular content that I wanted to show. So this is sort of a summary. And again, I sort of like this graphic, and I will admit that I stole it from the database team, just kind of modified it to make it work for me. But the idea is, again, portability. So you get this microcontainer to move things around. Density, I can put a lot of them together. And then, of course, you need the isolation to make them work. I can show you a quick like export import if we want to do something like that, like I can move from one to another, or we can just take questions.
So, with the increased density, monitoring, any changes to enhancements to monitoring other than saying run enterprise manager?
Right. So the question is, have you done any enhancements to monitoring to make this more monitorable in a more dense environment where you're going to have different things and not just run an enterprise manager? So absolutely. So first of all, it is still a single server, so there's still a single server log, but in each of those servers, each entry includes an identifier for the partition, so where all these things are coming from. And there's actually even a WST command to get you to generate a separate server log. So if you're autonomously managing these things, and I say here's your partition, then you're saying you're seeing an issue. Call me up and I say, yeah, I'll give you your server log, and I can email it to you, right? So I mean, it comes out as a log file when you're done at the end. There are some things that are naturally segregated, like a JMS server has its own log because you're isolated already. You get that web access; it's separate already. Then we also changed the MBean infrastructure. So for each of these pluggable partitions, there's a child MBean of the domain MBean for configuration. And then there's a child MBean of each server where it's running for the runtime MBean perspective. And then of that, there are child MBeans again, right? So your data source would have a runtime MBean that's a child in this. Your application runtime would be a child of that partition. So you get all that access. And it's separable, right? So you can say, admin 1 can only see this, admin 2 can only see that. So you can also set debug flags per partition. That's one that kind of I forget about frequently, but the idea is it needs to be manageable. Yep.
So if I care, would someone take a run at comparing resource requirements for containers versus multi-tenant? And a very good chart of multi-tenant resource savings.
Right.
How does that compare?
I don't think we've done the work on that yet, but
There's no idea. So that goes to the question, should I run partitions inside Docker containers? And they're gonna end up doing like Inception or something like that. The Inception movie putting stuff inside stuff. So the Docker model, the container model, and the multi-tenancy model, they all have their pros and cons. One is really like, hey, here's the image, just run it, right? On the multi-tenants, you still need the traditional, hey, install a logic, set up the domain on your production environment. Somebody will do that, and then the development team will provide the zip partition, and they'll say, hey, import this partition on your environment. The Docker model, it's like the full virtualized containerized operating system with WebLogic installed already. So the ops team doesn't even know what's inside, don't care, you just fire the container. Now the multi-tenant model, it gives more control on resources for the ops team. So it really depends on what culture, what architecture, what needs you have. Well, I think they did a pretty good job in providing more options here on how to run the WebLogic specifically. But again, it's more up to you to decide which one you save the resources or make you more fast or more agile or more like.
right. What's your priority?
Yeah,
What are your cost structures?
Deploying not too much, just save another 10% of resources.
Yeah.
Right. Could be that. Yep. Yep.
Those are
Other questions? Yep. Go ahead.
For so many of our infrastructure, we use like JVM, GI-based agent, native agent for monitoring the server in the workload, right? So, and they are all like bytecode different options for the agent for different applications?
I think it would depend on on the agent itself, right? I mean, this isn't coming
So,
from
like,
us, but
the simple question is, can I have a separate agent for separate application?
You mean separate agents for separate partitions on the same
Yeah,
server?
separate partitions.
So when you say agent, can I assume like New Relic agents like that, or something to monitor application, do some analytics?
Wiley Interscope, what's,
Yeah, so we use river backwards. Yeah,
Okay.
similar concept. It's like JVM architecture.
Okay, so the New Relic agent, for example, what it does, you're gonna put the New Relic agent on the class platform for JVM, but still your application needs to access the New Relic API to get data and then send to some New Relic server, right, to expose that information. So you would probably end up making the New Relic agent available to all the partitions, but it would depend on which application will be using the agent to get information for what kind of information wants to provide. That you would put New Relic on everywhere, but I think it would be possible to put New Relic agent on your application directly. I've seen people deploying the agent along with the application, like a library. So that's also possible. So, but you need to make sure that two applications, and that doesn't even matter if it's multi-tenant or not. If the two agents running the same JVM, they have the same settings, so you might screw up. So you have to make sure they have different configurations. But I think it's possible. But it's more up to New Relic agent documentation, not us.
Yeah, I mean, so usually the problem is not about collecting the metrics. The problem is about the class concept. Like one of the typical example is that they sometimes create the data loss because so they would have their agent trade which wants to collect some information, profiling information from the JDBC connection object.
Okay.
And so they have their own trade trying to connect the collect the JDBC connection information, and then application through JDBC connection object tries to connect to the database. And now what happens is that there is a data loss. I mean,
Okay.
it's a problem of prototype work.
Yeah.
But then in those situations, it's like I don't want you to do the instrumentation on this track, and that is something which you want to do it at the maybe here partition level, not at the container level.
Yeah.
So agent can run in either place, like just this information logic is actually
Yeah, I think it's something to check out.
Yeah.
It's more like we need to find out what options. Again, the same thing with Docker. We cannot certify all the models with Docker. I think for the New Relic on MT, we need to check how we can make it happen on an MT environment. We honestly we can go any further. We already ran out of time. No more questions. Sorry about that. But if you guys have some questions, you can approach us here. So thank you very much.
thanks for hanging out. All right.
Thank you so much, man.
Good, yeah, my pleasure. Pleasure. It's good stuff. Yeah, talked about this so many times. It's like,
My name's Rob. I work with CGD, it's Communications Global Business here.
hey, how are you?
And
Hi, Dave. Nice to meet you.
So this particular from which version of logic that was
WebLogic 12.2.1.
It's a 3D
Right.
drive.
The one that just came out Monday. Yeah, that's the one.
and we have multiple microservices running on a single domain. So the log
So,
especially your domain logs first.
So what kind of
Will you
web service that you would like to have access to?
logs or do you have to
Wow, I mean, so we're WebLogic.
So it's JavaOne.
So WebLogic, and then
See how they all fit together.
we can
But then
try
you can
and
extract.
Are you
We provide API.
part of OPN?
we're
Just give me the
part of-
log.
no, we're
There you go.
we're
Global log for different.
Awesome. Thank you so much.
But otherwise, they're all combined.
Okay.
So you can kind of see
Oh, okay, got it.
from one to
So
the next.
what you need to do is you need to escalate that with your managers. There's no other way except that.
Okay.
You need to escalate. Your manager will talk to his manager. Will talk with his director. That will
gotta
end
go up
up
to the exec
talking to
level,
the VP of the actual PM of the Java Code Service.
So it is possible, though.
It is possible.
Okay.
It is
All
possible.
right.
It's
Because like right now we're using the Utah Compute Center. We just
right.
we'd rather have
Yeah, it's
start playing with the cloud
so
stuff.
I have environment for until I guess it will last until 2016. But it all depends. You know, it depends on who you talk to, who they talk to,
Okay,
how they
I know
talk.
who to talk to in my org to get it escalated. I was just wondering if there's any sort of formal
So,
program.
you can go to demo.org.com and try there from the GSE environment, right?
Right.
I know it sucks, but that's what we officially have for internal people.
Okay, I have access to it, but that's only because for some reason there's a database somewhere that thinks I'm a sales guy.
Yeah, you can.
But most people in my org don't have access to it.
So demo.org.com works fine. You can find lots of stuff there. But if you want something more like long term for experimental stuff, then you're gonna have to go through a different channel.
Yeah.
All right.
Then I can have
Load balancer sits in front of that. It's all good.
and on each managed server, I can do some application.
Yeah, you just actually you can program clusters and then actually automatically spread it across the whole cluster. Because that's what you want. You don't want that, and you want internet access.
Right now we have applications for some reason we take down the application and for some reason after that balance not redirecting
And you should cluster. You should put them in a cluster. And are you using Apache as a platform? So what are you using?
no you fight.
That's fine. Okay. So F5 needs to know, right? That's what I figured to say. These are to address it, right? So as far as the application, we use Apache. We use
It's a application coordinator. So
we
what
tell
you
Apache put the membership in the cluster, and then it will automatically from those numbers.
But what happened is if you want to everything was first basically can have it to
Multiple VMs doesn't matter. Right? So it's a machine full.
That's the plan. Yeah, so down the road,
no, the limitation that we have is right now I think it was it doesn't sound
So let's get started.
yeah,
in fact according to our
just
because my
15
model
days.
Yeah, so
yeah, so we are
don't even start with
right now it's checking
do something else. Do Tomcat, whatever it is, just start there. Actually, so this is my request. Just go to doc.com, get a tutorial, and start it. Then if you want to fire up some applications, the tutorial has examples of that, web applications, you can find tutorials for
that's not information I think probably a perfect clustering application
and then when you get some information
but it doesn't work
how to
very
adopt it well, then you check
What license do you have today?
I think that's the best way, just get
You need enterprise edition.
So it
So if you have standard edition, you can't use a cluster.
just
You have enterprise edition.
I won't say a bunch of them, but
And it's worth it. It's worth those enterprise editions.
so it's a scale. So it's not only for
no. It's, yeah, there are people using production. Not many, there are people using production.
yeah, trusted.
Yeah. Not clustering, I would say distributed. Yeah, because most people use data computers, they don't communicate with each other. They don't have like replicated stuff like that.
So
The coding part. C'est bon.
Do you have HDMI out?
I think yes. I have also a standard plug if you. You have HDMI.
I've got HDMI. Excellent.
Never tested so. Okay, just close that.
Check your
The second screen.
yeah. I'm sorry.
It's not automatic.
There we go.
He tried to.
Uh, yeah. Oh, there we go. Let's see. Yeah, I need to. I'm not getting a signal here yet.
This is in French, so okay.
Je ne parle pas le français.
I think its configuration is.
See if you can get it to the extended desktop mode.
Yes, okay. Just go to panneau de configuration. Configuration, it's here. Configuration, affichage, apparence. I think it's here. Okay. Resolution. Here.
See? Yeah, we call it extended.
Double. Extended.
Yeah.
Okay.
Let's see if we get there. I had it open.
That's it.
Yeah. There we go.
We have signal now.
Now we got it.
Okay. Yes, I think I need to move. And
Doing coding demonstration?
yes,
Full screen.
I think even the full screen will not work. Let's work
Okay.
correctly. That's okay.
Fantastic.
Nothing here. I will just adjust the. It's okay.
Okay.
Okay. Just I will change the font of the. Right. Why it still work?
I'm getting it.
No, I didn't nothing. Just. It's a cable thing.
No, the cable's good.
The cable.
No, that's not it. Perhaps we try with the VGA.
Yes, it's better for me. Okay. So, better. Okay.
Okay, now we go here.
It's better for me.
Okay.
Perfect.
Okay, we have this microphone here. We can also use this clip-on mic if you want.
Yes.
So, either one. Okay. There you go.
Just I want to. Duplicate. Ah, it's okay. It's okay. Okay, and we have the code here. And well, okay. Just another Bluetooth server.
Okay. Okay. Like I say, are you going to be standing up, I suppose?
Yes.
Okay. Start at 4 o'clock. We don't.
think it's time. So, hi everyone. My name is Bassem Hamidi. I'm here to present about Angular Beans. So, just before we start, a quick show of hand, how many of you had been already worked with AngularJS? Okay, cool. Java EE7, so good. Okay, so in this presentation I will start by a quick about me, and after that I will spend approximately the half of the time to explain the why of Angular Beans, why I created this framework. So I will talk about the new web development challenges, Java EE7 and CDI specification, AngularJS, of course, and why I created Angular Beans. After that, we will make examples that show the framework features. So, and of course, 10 minutes for Q&A. I bring 9 years of work with Java EE technology, Java and Java EE ecosystem. As an R&D engineer at Esprit, it's a school of engineering in Tunisia. I'm Tunisian, so in Tunisia we don't speak a lot English, so I think you already figured it out. I'm a freelancer, a Java EE consultant, and a professional trainer. Okay. What I mean by new web development challenges. The new web context brings us new concepts like single-page application, thin server concept, real-time and fallback, hybrid mobile apps, loose coupling, client-server development, testability, productivity, and of course scalability. This is a classic approach of our web application. So we have our client, our server. Of course, the client will send an initial request. This initial request will trigger a session with the kind of session with the server. The server will respond with the first page, the first HTML page. Of course, that page can contain HTML, CSS, JavaScript. The rest of the interaction is get, post, and the server will always respond with new HTML. The server is responsible, of course, of backend services, HTML generation for dynamic web, navigation rules, UI logic, model view controller. The architecture MVC is technically implemented on server. Validation, of course, we can do some kind of JavaScript validation to avoid that. But generally, the server take care of the session, of the majority of session data, and it can be problematic with scalability. A standard client, of course, is responsible for HTML rendering, page reloading, forwarding, but we can have a more intelligent client called rich client that can do some AJAX requests to update some data, some part of the document, and prevent reloading, of course. But is this enough? No. A single-page approach is somehow different. By single-page application are not single-view application and are not single-screen application. By single-page application, we want to say it's the original DOM tree will stay there. We will not want to reload the DOM tree. And why? Because this kind of client is heavier. It contains more application logic. So we want to maintain a state. Those kind of clients are more stateful. Okay, we have an initial request. The server will respond with HTML, but with JavaScript and CSS. But here, the JavaScript itself, it's a totally client that can handle the rest of the operation. And the exchange will be just JSON. Okay, this kind of client manage HTML rendering, model updates, so he can update his model, routing. Of course, we simulate navigation on the client side. UI logic are there, validation, of course, and we can even manage majority of session data in the client side. Of course, via the DOM tree itself, HTML file storage, session storage, file storage. We have now what we call a thin server concept. The thin server is a server who is just responsible for services. He is responsible for data, but not how we should present this data. Okay, we have a lot of technology to do that, like Comet pattern, like JSON RPC, WebSockets, HTTP. Our server become more stateless, and our client become more stateful. And this model will enhance scalability, of course. And generally, we scale server, not client. AngularJS. It's a client framework. It's a framework designed for single-page application. It's good. He handles model view controller, model view model. They call model, we can say model view, whatever else. He has the two-way data binding, which allow us sometimes to avoid even the usage of non-necessary controllers. We have the notion of module, services, as service, as factory, as provider, blocks, like the run blocks, the config blocks, a life cycle. So he have controllers, of course, directive, event, watchers, filters. But what about the server side? Okay, so another important point is now we have what we call real-time application. And with real-time, we can have two kinds of real-time, simulated real-time and true real-time. Simulated real-time, we have tricks to do that, like polling, long polling, XHR streaming, HTTP streaming in general, server-side event. But a new technology as bringing the true real-time. This technology is WebSocket. Okay, it's good, but WebSocket can have two major problems. The first one is with the firewalls, because it's another protocol. The handshake initially is done with HTTP. After that, the client and server will do what we call an upgrade to change to the WebSocket protocol. It can have some problems with firewalls, and old browsers don't support that technology. And you cannot, when you develop a web application, say that the client will be able to use your WebSocket technology. So we have what we call fallback. Fallback is it's a big if then else in the client, in the JavaScript side. If we have WebSockets, use it. If we don't have WebSocket, we will switch to another solution, like simulating WebSocket. HTTP streaming, long polling. SockJS, did you know SockJS? It's a very good JavaScript library. SockJS help us to do all that. It's something that try to use WebSocket and try to do what we call the fallback. Via a fallback whitelist, he will choose the right protocol that will emulate WebSocket for this kind of browser. It will make life easier for us. We will not write our if then else. Okay. JSON. It's compact. It's readable. For web services is the JavaScript native object. It's enough for majority of needs. But as Java developer, we want Java object. We want to deal less with JSON, and it's normal. Java E7. Here I will mark the technology that the best, of course, of my opinion, the best technology that brought by Java EE 7 that can be used in our new web development ecosystem. So, of course, WebSocket, JAX RS2, JSON processing, JSON-P, and Servlet 3.1 with asynchronous support, of course. But I didn't choose JSF. I didn't choose expression language. But why? JSF use XHTML, not pure HTML5. I don't know if you have already tried to use a baked HTML5 template with JSF. So it's not easy at all. Okay, with JSF we have what we call pass-through element, pass-through attribute to try to be more adaptive with HTML5, but it's not enough. Okay, JSF have what we call life cycle. It's good for extension, but it's transform JSF a more complex framework to handle with big application. And of course, JSF has no idea about real time, is not even an event-driven framework, is not an action-based framework. Okay, CDI. CDI stands for Component and Dependency Injection for Java EE specification. So it's a reinvented component model for Java EE based on POJOs. He has a strong dependency injection mechanism via types, via names, qualifier, alternatives, producer, factories. He allows us to create our specific context. He has also a powerful event mechanism and a highly customizable framework via CDI extension, of course. So what we need a framework that is aware of single-page application. AngularJS do it already, but on the server side, we do a framework that is aware of Angular or aware of at least we have a single-page application. This framework, my solution is to use the power of CDI to easily integrate highly mature Java EE enterprise services or custom component, third-party library. But this framework will manage half-duplex standard HTTP and full duplex communication as the option and not different technology. If you know, with Java EE 7 have WebSocket, but WebSocket is like another framework different from JSF, for example. We cannot add in our JSF application real-time behavior without a third-party framework, like, for example, prime faces push, for example. Okay. We need a framework that abstracts all the boilerplate client-server communication. I choose an RPC style, remote procedural call style. And that's AngularBeans. AngularBeans, it's an integration effort between Java EE standard CDI and an AngularJS with the other side. I have a motto here. If AngularJS is what should have been HTML, if CDI is what should have been Java EE, AngularBeans is what should be JSF. Also with AngularBeans, Mustache, you know Mustache, the expression language with is your expression language. Directive are your tag libs. And directive are very, very, very powerful and customizable. No more GSP, no more XHTML. It's a framework that uses pure HTML5, of course. Principle, it's simple. Those are our Angular bean. Our Angular bean are standard CDI bean. So we can inject them into other CDI bean. They can use enterprise services like EGB, Entity Manager for persistence context. They can use everything that CDI offer. But Angular beans will generate from those beans proxies, Angular beans proxies. Those proxies will be AngularJS services. So ready to use, injectable AngularJS services. No boilerplate code. You will do anything to generate those services, and even without configuration. Of course, those services, we can inject them into our controller, our other, Angular services, and even on our directive, like any other AngularJS services. Okay, feature of the framework. It's a remote procedure call of CDI beans via HTTP, WebSocket, or any fallback mechanism. Bidirectional real-time event mechanism, you know CDI have what we call CDI events. And Angular also have an event mechanism that we fire this event, we broadcast those events in the Angular client. Angular means that AngularJS fire an event directly to the CDI context and vice versa. Okay. Publish, subscribe, real-time message broadcasting. We can broadcast message via public pub/sub mechanism. Path and action-based file upload. Generally, when we do general file upload, we use some kind of servlet to upload our file. With Angular beans, we have a single upload endpoint, but what we will do with this uploaded file will vary following the path mentioned here. It's a REST style of file upload. Okay. Internationalization based on property files will be transformed on JSON. Bean validation. When we Java EE have what we call bean validation, and we can do in our HTML side HTML5 validation. But when changing our application, we can changing our bean validation rule in the server side, but forgot to simply, for example, HTML5 validation attribute. But if we have to declare only once the validation rule, as for example bean validation, and the HTML side will follow that, it will be more easier. Okay, overloading. Java have the overloading. Java, we have not JavaScript overloading. So when I said that I will call my services with RPC style, we can have easily a CDI bean that dispose of overloaded method. So how we can handle that? The framework handle that automatically. Okay. The binary content handling also. Logging, we see that. Handle course request. You know the cross-domain request problem. So, okay. Model query. This is a kind of patches of our data. This kind of patches that the server will ask the client to change his model. You will see that. For me, it's cool. Huh? Okay, so let's go to the demo. For this demo, I'm using Eclipse and Whitefly 9. The connector mentioned that is Whitefly 8, but it is Whitefly JBoss Whitefly 9. It's a full profile Java EE7 application server. So it's pretty simple. I will create a new Maven project with M2 Eclipse. We have already prepared an archetype, a hello world archetype. His number is, I think, 85 in the Maven central repository, if you use the command line. Okay, group ID Angular beans JavaOne. I will call it hello world. Version, I will maintain that. This is our hello world. Let's see the structure of the project. We have our web app folder. We have our source folder. It's a standard Java EE web application. We have a single package here, a single class. We'll see that later. But let's concentrate on our web app. So we have our index HTML. For the organization, you can use any organization of file you want. I declare controllers, directive, filter, module, services. In this example, only controllers and module are filled because I have only one controller and one module. This is my module, Angular.module, my app. But here, this is what we call a dependency of module. When we have a module that depends on another module, we declare like that in AngularJS. We have a module called Angular beans. So, so this is my index. It's a pure HTML5 file. We have JavaScript sources that point to our JS structure, but also the AngularJS dependency, sock.js. Sock.js here is optional for the beginning, but it will be useful later. And Angular beans.js. I think you remarked that I haven't a source.js called AngularJS. This file will be generated from the server. It's via servlet. Okay, so you have just to add this. This JS will produce a module. The module I declare here. What contains this module? He contains services, ready to use, and other extra feature. Okay, this part is optional too, to handle real time just to show, but we can have something without any configuration. So I declare just a module. In that module, I declare a controller. I take a look on my controller. Scope. What's that? It's hello Angular beans. It's a services. But the service is not written here. The service is written here. This is our CDI bean. Simple. It's a Puju. This is a method, say hello. Of course, we pass as parameter name and we return hello name from Angular beans. A simple scenario. And here I declare my services. Here I directly inject him into my controller. So no boilerplate code. And when I need to call this method, say hello, I just call it. Of course, it's the JavaScript world here. We have, it's an asynchronous treatment, so we have to deal with promises. And when we have the promises of the response of these promises, we can update our response. For example, it's a model called message of our scope. And here the method declaration. Okay, I will just execute that. And here, JavaOne. And hello JavaOne from Angular beans. Pretty simple. Let's, okay. This method is called via normal HTTP. It's an HTTP GET by default. Of course, if you want to send a post, do it like that. It will be a post. The name will be in the, not be in the URL. If I want to call, say hello with WebSocket protocol, I just do that. The real-time annotation. And you simply switched from standard HTTP to WebSocket. And we not deal differently with the two technology. It's the same thing. I want WebSocket here at real time. And the framework will do all the rest for us. Of course, why at real time and not at WebSocket, for example? Because we are not sure to use WebSocket here. If we have some kind of client that doesn't support WebSocket, what do AngularJS? AngularJS, if you simply add this SockJS dependency, AngularJS will detect that, and will, when we haven't WebSocket available, AngularJS will let SockJS handle the situation, and SockJS will choose the right protocol for us that we will always work with any kind of browser. But all that without an additional single line of code, without any configuration. Okay. Now, I will add something to our code. If, for example, I want to have something like that, int, counter, private, and I want, for example, every time I call say hello, I increment the counter. Pretty simple, counter, plus, plus, and a condition if counter equal 10, for example, 10 time. I want to log onto the client side a message, to use log. Normally, I should add something to the JavaScript, but I will not doing that. I will use something called ng-logger. And simply ask CDI framework to inject that logger. Okay. And when I need log, I do that logger, log. If log level, for example, debug, and the message and some option. Donc here, for example, you called hello, or I want to say hello. Person D, X, counter here, sorry, times. I think I imported something. No, it's okay. It's the level of the library. It's simply a level, not log level. Okay. Now, I have to to increment the X, but this Angular bean is by default a request scoped. So for every request, the X will, the counter will always be initialized at 0. We can use another scope, ng session scoped. And why the ng session scoped, not a standard session scoped? Because we cannot bound, even with CDI now, we cannot bound this bean with two contexts, the WebSocket context and the standard HTTP session context. We have a problem with that. So with Angular Beans, I created a new kind of context that merge the two. So we can, for example, do a first call with HTTP GET to a method, and the second call with via WebSocket, but we'll always have the same instance for our session. So it's an ng session. It's a session that includes the main HTTP session with one of many WebSocket sessions, because you can have many tabs opened in your application, so you will have many WebSocket sessions here. So all that is called ng session here. Okay. It's just to increment our counter. And I want to, okay, I'll just do it like that. Publish. This is a problem with the server. Clean. Okay. Now I just will open the console tab here. JavaOne. I will try to click 10 times. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, you call it say hello 10 times. This is the log. It's simple, but I want to see the counter incrementing. So how I manage that, and I will add a getter for my counter here, and I will define this counter at ng model. An ng model, I want to say here that in the server and the client side, in the JavaScript side, the proxy of that Angular bean, the Angular bean proxy, will have also a model called counter. The problem here is not for the beginning. From the beginning, the counter will be initialized at 0. You will see 0. The problem is when you click, you update the model. And my framework don't work like JSF, that he will not always call all the get he found. No, you have the finest control over what you want to send to the client. So for that, it's applicable for real-time methods and also for standard HTTP method. So I can, okay, I use a notation called ng-return. And here I want to say, after the execution of that method, what client-side models I want to update. So it can take an array of updates, and I want to update the counter simply. Okay. I didn't like much this kind of code. It's even the Angular developer called that the scope soup. We use a lot of scope. This application will be not very maintainable, and we have also a problem of testability. Scope is a contextual thing. It's not easy to test. Because of that, they use another style called the dot style and the scope soupless style. It means that you can not using scope at all. I will use my services, and I will declare my controller as an object, and the controller will be the scope. I can also not declare that. I will like that. Just I will do var view model equal this, the instance of the controller, and I will attach a function onto, to the view model. View model, for example, hello Angular beans equal hello Angular beans. So I attached my service here to that view model. Okay, that's enough here. But I need to change my index HTML file, where it's another syntax used to tell Angular use your controller as class. So it's as my controller as view model, for example, and I will use view model.name, view model dot not say hello view model, the name of my this one, my services. I will call it directly from here. View model dot hello Angular beans dot say hello, and I will pass it view model dot name. This will help us a lot with what we call also the scope inheritance problem, where we have many scope inheritance problem. Here we have a kind of naming convention, kind of protection against that. Okay, with this Angular style. So ngIf is just to show the message here. So dot message. I think it's good. Okay, but we have problem here. When I used the controller, it's the controller that called the services. They handle the response, they handle the promises, and they update the model. How to tell to my Angular beans that when as a response, I want to update messages. And the string has no name, is not a property, is not a parameter. It's a type. So here we can use another attribute of ngReturn, call it model, is the main return of this method will be bound to that model messages. In other words, when you finish your say hello method, update the message with the return of that method. So we can handle that. And for updates, we have my counter. It's okay. JavaOne. The message, but is empty. It's in the HTML. VM Anglo message. Yes. Of course, we must continue with that. Okay, here I modified the HTML. I don't need a full publish, of course. Just when I touched the Java site. Okay. JavaOne, and that work fine. With a better style, it's an AngularJS thing this time. Okay.
Can you show the resources? Can you show, you were saying the services generated server side, right?
Yes, but here, I think I have a small problem. Console, network. No, that's the initial request of the WebSocket. Resources, I don't know what to handle that. When, I don't know how to show that. Okay. Anyway, okay. Just I'm not, return to that console. Okay. You want to know the data structure?
I wanted to see, you're in essence, you're generating these services on the fly, right?
No, not the services. I have multiple steps of generation. I have a first step called static generation. I can detect the static part of your Java code, annotations, and generate services from that. But for example, for initialization, I need instance to call the getter and get the initialization. It's the second level of generation. And this part is generated as the fly, but it's a small part to optimize, for example, performance. But because the static part are shared with all the instances of the Angular beans, but each instance can have different value, so the dynamic part, it must be smaller to enhance performance.
Right, but when you were defining the structure of the Angular application, right,
Yes.
you specified the dependency to what's coming from Angular beans. Right?
Okay.
That doesn't exist.
Yes.
So I assume it's getting pushed.
No, because it's just a servlet that will generate the JavaScript.
Right.
Okay.
And that's what I wanted to look at, is what is that JavaScript?
JavaScript. Okay, so just I call it Angular beans.js. Is that? Okay, I use a Clojure compiler in the server side to just minify what I generate. We have here a part of a code that static, for example, built-in features, some feature related to file upload, to internationalization, we will always use that, and some dynamic part related to our Angular beans themselves. Okay.
Is there anything that we need to take into account as 2.0 starts to come out, right?
Sorry,
AngularJS 2.0. Is there anything that we need to be concerned about if we start adopting?
Okay. So in this version of I work with Angular 1.4. Okay. It started like a proof of concept.
Right.
But it's now more than proof of concept, but it's still not production ready yet. It's still, we will a lot to change on that framework. For example, the lazy loading part, because if you define 500 services, you will have 500 services defined on your initial JavaScript, and you don't need that now. So we'll do some kind of lazy loading of defining many modules, and you can just with JavaScript what module you want exactly. You have the main module and submodule. This in our roadmap. To move to Angular 2, we want to wait, because we wait to adoption of Angular 2 in the world, so I would say. I'm alone on this project, so this is my limit here. So one of the reasons I came here is to find some contributors, some guys who want to help me on that project. It's an idea, plus then it's not something that really will package that. It's an open source framework, yes, but it still need enhancement. But the concept is cool. You understand what the concept is cool. It's easy to use and it's powerful. You understand what that's okay. And switching from real WebSocket, real-time ability to HTTP GET without any efforts. And we can, for example, here we use Chrome. For example, I can show you in that part. Here, for example. This configuration, I didn't use it from the beginning, but I have what I call a built-in service called Real-Time Manager Provider. It's the way of Angular to configure services. You have options, protocol whitelist. That here I want to say it's a SockJS thing. So if we have not WebSocket, this is the list of protocol you will switching on. But it's not an order. SockJS will select the best protocol for the browser. But you can simply just take away an element, so he will switch to another. It's not an order. It's a whitelist. Okay. Debug to show us what SockJS do. Here I will disable to simply the WebSocket. So real-time manager provider WebSocket enabled, false. Now I will simulate a client that doesn't dispose of WebSocket technology. And we have SockJS that switched to XHR streaming. It's an HTTP streaming. Of course, even if I change the place that here, it will always choose the same thing, but it's the preferred protocol. If I wanted not to do it, I will simply drop that. Okay. Now he will choose the next protocol to send. He has chosen iframe event source. Okay, it's SockJS who do that. Just here, if you want explicitly doing something, but it is optional. Huh? Okay. So another cool feature of this framework is what I call a model query. Model query, it's use it like that. Model query, models. For example, I need just to inject that. And if I want to update a data table in the client side, I just ask the client to update her data table. For updating, for example, a data, a table, I don't need to send all the new version of the data table. I just ask the client like that, models dot remove from, for example, the name of my table, for example, users, and a specific user instance that or something based on ID, for example, user, I don't know. It's used like that. We can do something like remove from, add to, set a property, and you will, it's a builder. It will create a model query, and he will fire the model query with the return of that method to the client, and you will see that the model has changed client side. Yes, of course, it's half duplex behavior now, but you can inject something other. It's called real-time client. This client will allow us to broadcast events with real time, to technically broadcast even model query with model query models, for example. If here, for example, I want to update all the data table of all my clients, I will use the client, real-time client, dot broadcast, and my model query. This without me, of course, if you want, when you broadcast this model update, if you want that will apply to you or not with all the group. So if I set that to false, I will be also notified with this. The actual session will be also updated his model. It's a cool feature also. So I can do a small test for that. So for example, I will say that in my controller or in my Angular beans, I have something like that. I can use a public void init. It's a post construct CDI block at post construct. I can declare a list of something here, a list of users, for example. Of course, not users. And the user can be something like that. Privacy name, have it in the ID, I don't know. Getters and setters. Okay. So in my init method, I will just have some users as I bring them from database, for example. So users equal new array list, for example, also. Of users. I will use, I will add a default constructor override here, using field. Okay, so now I can more rapidly create new array list of users. Here I will add new user. Oh, well, of course, arrays as list. Array as list, and here I will add my users. New user, for example, name, ID, user 1. 2 user is sufficient, so I will add another user, user 2, with an ID 2 and a comma here. Okay, so with post construct, I will have a list with 2 users. In my client, I will add. I want to have a button. When I click on that button, get some users of something like that. So I will create a public list, or it can be even a void. Public void get some users. Just imagine scenario here. And we can use our models. Set property, it's a property of on the client side that can be named users, of course, and users, just for to have the first list of users here. So model set property user users. Okay. And here I just need to use that on the HTML side. For example, I can create a UL to be simple, just to li ng repeat, and I need view model Angular beans users. Of course, here it be user in VM view model hello Angular beans user, and here I will, for example, show just the user dot he has what name. Just I need to still on the scope of the controller. Huh? Okay. Just a full publish because of the change on the Java side. Clean. I forget the button will call that method, get some users. So I didn't need another full publish, but I will add here, for example, a button. ng-click. Get some users, something like that. Get some users. Okay, so test. Here I have my button. I click. I didn't have the user. I don't know what I have done. Hello Angular beans. Get some user. Just ng return. That didn't work. I didn't. I'm not really prepared for that. What? Into beans? Yes. Users. Users equal. No, it's okay. No, it's supposed to work like this. Model set property users. Yes. Users. Okay. I think it's more on the index. In user.name. user in users, user.name. Okay, no, there's another problem. Something. UL.
What's the annotation ng model actually doing?
Just ng model.
So you
No,
have
no.
ng return there, but above you have ng model because you're touching an element on the model.
Here, this model is defined on the bean itself. Here, the model query. Where is the model query? Inject model query. Here, the model query can handle client-side models that doesn't exist in the beans itself. So, for example, users can not to be a properties of that bean. This can be something directly called from database users and return those users, and not declared as a property of that bean itself. So, but when the other way, when I declare ng model here, it's something who exists in the Angular beans here and in the client side. It's not the same way of do it. So I wanted to do it with this way, model set property users, users. So ng post construct. I think I have a little problem here. Yes, is this annotation I need to do it with at real time when I have real time. Why? Because with real time I call it with WebSocket, and with WebSocket when you use a void, the server shouldn't return a response. It's not like HTTP. You must have a response. So if you want to have a response in the situation like this to update models of something, you have to add ng return with the real time. So, but I didn't need it in my situation because I think it's the method itself. It must be the name of the method, technically, because I know there's no exception handled at this level. So get some users. What?
What would make the UI to update? Like you get some users, it's called the Java, but it didn't refresh the LI. It didn't refresh the UI.
Yes, it's supposed to be refreshed automatically. Okay. Just the problem here is that it's supposed to. What?
Maybe you need Angular.
It's I already tested that scenario like that, even a more complex scenario. It's supposed to work. It's supposed to be updated automatically. It's the meaning itself of models. Of course, we have a lot of bug with the framework, and now it's still new. But I want to show you the idea. It's most important in this session. Yes.
You call get users and
get some users. User in user. It's here is in the local scope.
No, that's
in
fine. But the
VM.
Users itself, right?
Yes.
Go back to the main.
No. Okay.
So where's it going, right? So you say get users.
List users new as list. Here I initialized the value is sure. I have some users here. I just add, to be just quick, a system out. I will just show my, not here. It's just game. Yes, but I don't disturb users, for example. To check two things, that the method are called and the list of users, but I have test, and we have nothing here. If the method was not called at all, it's not a refreshment problem. So it can't be not get some users. So public void get some users. Okay, I add a get here. I didn't need it normally. I will add it. Get some users, and I will manage to. Is not really. With get is not really important with get. I will add it, so because it can be just a bug, so return. It's not supposed to do it like that. No, there is no JavaScript errors. This is why it's difficult to debug for me now. It's some kind of, the framework didn't call it that method. Get some users, void, ng return, add get. Yes. In this situation, I need to add get. Okay. Why? I forget that. I forget my own framework, how he works. Okay, I have, okay. So he have so many other features, and 1 hour is not sufficient. I even can't imagine what is the examples to show or the feature of that framework. So here, when he found at get, Angular beans will support, it's a bug, because it's a void, but it will suppose it is a getter. And the getter will not be called automatically without updates here. Yes, you know, it's not the same concept. It's supposed that, and that causes a bug in the client side. When I mention at get, it's kind of, I force the thing is not a getter. It's not a standard getter. Okay, but it's not normal because a void is not a getter. So we might enhance that in the framework, of course.
Now, if another method updated the user set and added a new user, will this reflect in the UI?
Excellent. If, for example, here, just public, I want to add a method just that remove a user, for example, from here. You're removing or adding, it's the same thing. Removing is more easy for now. So public void also, remove, and you pass a user in parameter, user. Okay, here I will use models dot remove from, and I will remove from users, of course, that user. And you can use remove from, add to, for example, to move a user from a list to another. Use remove from that list, dot add to, set another property, set the title, add this. Okay. And what is cool with the models, that can be broadcasting with the real-time client. This feature work with the current session, but it can be broadcasted to all the session. It can be something like I update my profile image, and all the client will see their image profile updated. It's work like that. But we have, it's not a publish subscribe model. It's kind of update your models. It's the new, but we have for that other thing, the real-time messages are event sended for subscribe. It's not the same. We have the two mentality in Angular beans. So it's for that the real-time client. The client can broadcast a model query or a real-time message, but with a channel. Okay. Broadcast this message in this channel, and the client can subscribe. It can be very, very, very helpful to do a real-time application. Okay. So just to remove the user. It's not a get, so it will not have any problem with that method. I didn't should be used get. So user int user.name, and we'll just add here, for example, a button. It's not really normally with the UI, but button is not. I can add a button. I can add a button here. Button. That is not, it will not be repeated because I want to remove the current user. So yes, button, remove. ng-click. And my services, not remove what the current user, so the user. I think it's okay, yeah? Okay, remove. Just I verify the method name, it's remove, okay. Because I added that. Test, I loaded my users, and I remove a user. It's as simple as that. You want, and yes, of course. Now, just with that, I will. Okay. And now I will use that. It's another client. Okay. For now, it will work only for one client. But if I change, just I use my real-time client, the behavior will change. Of course. For example, this one have this user. This one will have those user. But here, when I remove, for example, when I remove from the side, it will be removed in all the sides. Okay. In just, I will change something. Real-time client, sorry, dot broadcast this model, that models removed from user, can be like that. And without me, I will say that false. Me also, the current session will be updated and the other session will be updated. Okay. And remark, I called remove with HTTP. And this behavior will be with WebSocket. Okay, I load that, and it's removed to side. Understand what I? Okay. Okay, I'm really sorry. So I didn't have enough time to explain many other features of the framework, but you can find by this night I will commit this example, but those examples in the session. I will try to add more examples what I wanted to do tomorrow. So in that repository, of course, Angular Beans is not in production yet. For example, asynchronous support with UGB. You can use UGB, you can inject UGBs, but the reverse is not. You cannot handle the asynchronous call to UGB, for example, maintainability and test also. Okay, thank you.